udah delay. Udah sih. Iya. Ini udah muncul. Coba kita video suaranya keluar nggak?
The Faculty of Industrial industry opportunities and extensive professional connections.
Ya apa?
We are supported by expert
Kak Ari,
lecturers and
ayo.
competent support.
instructed otherwise. Stay calm and do not panic. Our team will assist you to the safe location. Thank you. We hope you will have an enjoyable and wonderful experience at the Trans Luxury Hotel, Bandung.
Ladies and gentlemen, from the grand ballroom of Hotel Bandung, please give applause and welcome our master of ceremony, Anas and Amara.
Bismillahirrahmanirrahim. Good morning, everyone, and welcome to ICSMech 2026.
My name is Amara.
And my name is Anas.
It's our pleasure to be your host for this morning's opening ceremony. The Honorable Chairman of the National Research and Innovation Agency, BRIN, represented today by the Chairman of the Research Organization for Electronics and Informatics, Professor Dr. Eng Budi Prawara, the Honorable Rector of Telkom University, represented today by the Dean Research Institute, RICCSL, ASOK, Professor Dr. Bambang Setia Nugroho, ST, MT, the representative of the IEEE Indonesia section, our distinguished keynote speakers and panelists, honorable official of BRIN and of Telkom University, representative of our sponsors, and all of our participants.
It is a true honor to have you with us today for the opening ceremony of ICSMech 2026. This event is organized by the Research Center for Smart Mechatronics, Pusat Riset Mechatronika Cerdas of BRIN, in collaboration with the Faculty of Industrial Engineering of Telkom University. It is also made possible through the generous support of our sponsors.
We would like to acknowledge and warmly welcome our deepest appreciation goes first to Pelindo
Unitronic Jaya,
and Intechno.
please give a round of applause.
Our warm thanks also go to Trakindo,
PT Star Perkasa Teknologi,
PT Manvis Technology Engineering,
PT Rekayasa Hijau Mandiri,
and Dewesoft.
please give a round of applause.
And our sincere appreciation to our operational support partners, BRI.
And Wuling.
Please give a round of applause once more. In conjunction with the conference, we are also proud to host BEST 2026, the BRIN exhibition on smart technology on display just beside the registration desk.
Ladies and gentlemen, the opening ceremony of ICSMech 2026 is about to begin. Please ensure that your mobile devices are set to silent mode.
Ladies and gentlemen, to begin our ceremony, all please rise for the singing of our national anthem, Indonesia Raya. To all participants, please rise for singing Indonesia Raya.
Please be seated again.
Ladies and gentlemen, in the tradition of Indonesian hospitality, it is our pleasure to welcome our distinguished guests with a performance of the ronggeng, a traditional welcoming dance that embodies the warm spirit and cultural richness of Indonesia. Please join me in welcoming our performers to the stage. Distinguished guests, ladies and gentlemen, it is now our privilege to invite the General Chair of ICSMech 2026 to deliver the welcoming remarks. Please warmly welcome to the podium Dr. Roni Permana Saputra, MN, SC, PhD.
Oke, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi and very good morning everyone. Distinguished Chairman of the Research Organization for Electronic and Informatics, Professor Dr. Eng Budi Prawara. Distinguished Dean of Research Institute of RICCSL, Telkom University, Professor Bambang Setianugroho, respected keynotes, panelists, invited guests, authors, participants, college, and friends. Welcome to ICSMech 2026. On behalf of the organizing committee, it is my privilege to stand here before we start the second international conference on smart mechatronics. So 2 years ago, ICSMech start its bus in Yogyakarta, and then to see it come back larger, more international, and more ambitious, it is our commitment to our community, and it is an honor for me to share this moment with you here in Bandung. And the response from our community to this conference has been remarkable. From more than 300 submissions, we have accepted around 120 peer-reviewed papers. So it's about 50% rejection rate. So it shows our commitment to uphold and to maintain the quality of this conference. These accepted papers represented the researchers from around the world, from Indonesia, Japan, Malaysia, Vietnam, the UAE, the UK, the Philippines, and beyond. So I thank every author who trusted their work to us, and also to all the reviewers who gave their time to set the standard for this conference. And over the next 2 days, the program unfolds across 6 technical tracks. It's from robotics and system intelligence to autonomous vehicle and smart machine, dynamic control and system modeling, intelligent instrumentation and embedded system, biomechatronic and smart assistive system, and information system for mechatronic. Each is a frontier where fundamental science meets real-world impact. So we also honor to welcome our distinguished keynote and panel speakers from leading university and industry from here, Indonesia, and around the world. Their perspective span fundamental research, applied engineering, industrial practice, and they will, I'm certain, set the tone for the conversation ahead. This year, we are also proud to introduce BEST, the BRIN exhibition of smart technology, and this is a new addition to ICSMech. This built around the idea that technology should meet sustainability. BEST is a student innovation showcase that bring university teams together to present practical solution to real-world challenges. So I warmly encourage all of you to visit to see what our students have built and also to support the next generation of innovators. A conference of this scale is never the work of one group alone. So I'm deeply grateful to BRIN and also to our co-organizer, Telkom University, for their partnership, and also to the IEEE Indonesia section for its support, and to all collaborating academic institutions whose involvement give this event its breadth. I would also to express our sincere appreciation to the sponsor and partners whose generosity made this event possible. Our deepest thanks to Pelindo, Unitronic Jaya, and Intekno. And also to Trakindo, PT Star Perkasa, PT Manvis Technology Engineering, PT Rekayasa Hijau Mandiri, and Dewasoft. And also to our operational support, BRI and Wuling. Your support is what allow a gathering like this to take place, and we're truly grateful. And also to every member of the organizing committee, you are the people I am most proud of today. So you turn the idea into the day we now begin. And you did it with a dedication, and it humbled me more than once. Thank you, everyone. So let me close by wishing all you the productive and memorable conference. Thank you very much for being here with us, and enjoy the ICSMech 2026. Thank you.
Thank you, Dr. Roni Permana Saputra, for the warm welcoming remarks. Ladies and gentlemen, ICSMech 2026 is proud to have the support and endorsement of the IEEE Indonesia section, the Indonesian chapter of the world's largest technical professional organization, the Institute of Electrical and Electronics Engineers.
Unfortunately, the representative from the IEEE Indonesia section is unable to join us in person today. However, they have kindly shared a video presentation with us, so let us now turn our attention to the screen.
Bismillahirrahmanirrahim. The Honorable, the Head of Research Center for Smart Mechatronics, National Research and Innovations Agency, Republic of Indonesia. Assalamualaikum warahmatullahi wabarakatuh. My name is Kurnianingsih. I'm currently serving as the IEEE Research Section Chair and IEEE Region 10 Vice Chair of Professional Activities. I'm also serving as the Committee of IEEE MGA IT Coordination and Oversight and Committee of the IEEE MGA Ad Hoc on New Audience. On behalf of the IEEE Indonesia sections, it is my great pleasure to welcome all of you to the second International Conference on Smart Mechatronics, ICSMech 2026, which is hosted in Bandung. This year, the IEEE Indonesia section is honored to serve as a financial co-sponsor for this conference in close collaborations with Research Center for Smart Mechatronics National Research and Innovations Agency, Republic of Indonesia. This sponsorship underscores our strong commitment to strengthening the quality of conferences in Indonesia. I would like to extend my heartfelt congratulations to the organizing committee under the leadership of the General Chair, Dr. Roni Permana Saputra, sponsors and supporters. The dedications and hard work have brought this important platform for knowledge sharing, collaboration, and innovation to life. I would also like to express my sincere appreciation to all speakers for your willingness to share your expertise and cutting-edge insight. And of course, I would like to extend my warmest thanks to all participants for joining us today. For you who may be new to the IEEE is the world's largest technical professional organization, which has over 500,000 members in more than 190 countries. IEEE now has more than 189,000 student members. Our mission is advancing technology for the benefit of humanity. IEEE is leading in standards, publications, and conferences. Here in Indonesia, the IEEE Indonesia section was officially established on 16 February 1988, and this year marks our 38th anniversary of empowering local innovations and global engagements. As of last year, December 31st, 2025, our members reached more than 3,000 members. I'm truly privileged to lead the IEEE Indonesia section this year, supported by a passionate and committed executive committee. Our strategic directions is shaped and strengthened by our esteemed advisory committee, who are the past IEEE Indonesia section chairs, whose visionary leadership continues to guide our growth and development. Currently, IEEE Indonesia section has 18 chapters and 8 joint chapters, and we also have 12 affinity groups, including women in engineering, young professionals, and site. We also have active 45 student branches and 18 student branches under chapters. Our strategic focus in IEEE Indonesia, we have our motto is unity in diversity, bridging cultures, empowering innovations. We have 7 strategic programs. First, integrating diversity, equity, and inclusions across all activities and partnerships. We strengthen collaboration between academia, industry, government associations, and the wider community. We also focus on advancing humanitarian technologies and promoting impactful community service programs. We also focus on improving the quality of IEEE conferences and publications in Indonesia. We support the professional development of students, ensuring a smooth transitions into the global workforce. One of our focus is reaching new audience by identifying underserved communities across geographic, professional, and demographic lines. We promote cross-organizational unit collaborations to expand our reach and impact. This conference has 6 main topics, including robotics, perceptions, automations, vehicle and smart machines, dynamic control and system modeling, intelligent instrumentations and embedded system, biomechatronics and smart assisted system, information system for mechatronics. All these 6 main topics embodies IEEE mission to advance technology for humanity by emphasizing practical solutions in critical sectors, transforming industries, enhancing quality of life, and fueling innovations. The work you present and discuss here will have far-reaching impacts across many sectors. As a chair of IEEE Indonesia sections, I'm truly excited to witness the exchange of ideas and creations of new partnerships, and the collective of innovation during this conference. Let us continue to collaborate, inspire, and lead as we advance technology for humanity together. Thank you for giving me the opportunity to address you today. I wish you a truly successful, productive, and memorable experience at this conference. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you to the IEEE Indonesia section for those remarks and for your continued support of ICSMech 2026.
Ladies and gentlemen, we are traditional welcoming dance Ronggeng. Maybe they were late because of traffic jam.
Let us now enjoy and please join me in welcoming our performers to the stage.
Nyi Ronggeng loba nu nganggap saukur dongeng nu teu puguh juntrul jeung rengkolna ukurna trat jadi sajarah sastra pitutur tapi sing ingat hiji basa nu geus lana tinangtu aya sasakalana saha nu haat saha nu iceus kana ieu perkara lodaya puragabaya gesan tandang sajamidang lodaya maung karuhun ngagaur anu ditunggangan ku raja kami nace permana bari ngabar pusaka kujang kabuyutan Karawang. Malulu biasa para pejuang para karuhun nuges pae kosok nandonkeun jiwa jeung ragana pikeun kamardikaan negara tapi jeung anu disebut pejuang bisa kabeh kudu rongkah di medan perang di Karawang Nyi Ronggeng midang najan narah di raga tanpa sukma tapi inya berisi upagi nggoning bebela kalemah say syakur ningali kaeret kupel bawa nyeronggeng ngalit lain alat pikeun gini pikir curang lampah tapi sasireun sabeunyereun pikeun modal perjuangan
Ladies and gentlemen, wasn't that wonderful and spirit performance? Please join me once more in appreciating our talent performers.
Ladies and gentlemen, our next distinguished speaker, delivering remarks on behalf of the Rector of Telkom University. Please warmly welcome to the podium the Dean Research Institute RICCSL, ESOC Profesor Dr. Bambang Setia Nugroho, STMT.
Would like to read the welcome remark from Telkom University. Okay, Assalamualaikum warahmatullahi wabarakatuh. Distinguished keynote speakers, respected researcher, academician, industry partner, government representative, panel sponsors, academic collaborator, and patron, and ladies and gentlemen, good morning and welcome to everyone. It is a great pleasure for me, on behalf of Telkom University, to welcome you to the International Conference on Smart Mechatronics, ICSMech 2026, jointly organized by Telkom University and National Research and Innovation Agency of Indonesia, or BRIN. We are truly honored by your presence. Researchers, engineers, scientists, practitioners, and students from different institutions, disciplines, and countries have come together here with a shared commitment to advance knowledge, exchange ideas, and contribute to the development of science and technology for the benefit of society. First of all, I would like to express my sincere gratitude to our keynote speakers and invited speakers for generously sharing their experience and insight. We are for your willingness to contribute to this conference and to inspire meaningful discussion among participants. I would also like to extend our deepest appreciation to our sponsors, supporters, and patrons. We gratefully acknowledge the Techno Group, Pelindo, Unitronic, JS Sakti, StarTech Indonesia, Manpis Engineering, Ubisoft, Rekayasa Hijau Mandiri, Trakindo, and Wuling Motors Indonesia for their support and trust in this conference. Our sincere thanks also go to our academic collaborators. We are honored to work alongside Institute Technologies 10 November as the principal academic collaborator, as well as Universitas Sriwijaya, Universitas Pembangunan Nasional Veteran Jakarta, Universitas Diponegoro, BINUS University, and Universitas Pendidikan Indonesia. Your collaboration reflects the spirit of partnership that is essential for the advancement of science and innovation. I would also like to acknowledge the dedication of the organizing committee, reviewers, volunteers, and all individuals who have worked behind the scene. This effort have made this conference possible. Ladies and gentlemen, the field of smart mechatronics continues to evolve rapidly. Advance in artificial intelligence, robotics, automation, sensing technologies, and intelligent systems are creating new opportunities while also presenting new challenges. No single institution, discipline, or country carries this challenge alone. Progress increasingly depends on our ability to learn and from one another, to collaborate across boundaries, and to combine our diverse perspective and expertise. In this regard, Conference 2026, your presence enrich this conference, and we are delighted to have you with us. We wish you an enjoyable, productive, and inspiring conference. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Asok Professor Dr. Bambang Setia, for those encouraging remarks on behalf of Telkom University.
Your Excellencies, distinguished guests, ladies and gentlemen, we now come to the most significant moment of our opening ceremony, the opening speech, which will also formally open ICSMech 2026.
It is our honor to welcome the representative of the chairman of BRIN, the National Research and Innovation Agency of the Republic of Indonesia.
Ladies and gentlemen, please join us in welcoming to the podium, representing the chairman of BRIN, Professor Dr. Eng Budi Prawara. Please give it to us.
Assalamualaikum warahmatullahi wabarakatuh. Very good morning to all of you. Yeah, first, I would like to convey sincere apologies from our chairman because he could not join this conference on this morning because he has a very important agenda. And yeah, please allow me to deliver his opening remarks. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And very good morning to all of you. Distinguished guests, Professor Bambang Setia Nugroho, Dean of Research Institute, RICCL, Telkom University, our distinguished invited speakers. Yeah, we have Professor Michael Milford from Queensland University of Technology, Professor Yoga Dharma Setiawan, Director General PTLN Industry, Professor Keisuke Morishima, Osaka University, Japan, Professor Dr. Abdul Wahab, from from International Islamic University, Malaysia, and also Professor Dr. Maman Abdurrahman, Head of COE Pratama Advanced ICT Infrastructure and Service, Telkom University. And also our honorable colleagues from the Center for Smart Mechatronics, Professor Yanwandri and College, and our partner at Telkom University, esteemed researchers, industry leaders, and innovators joining us here in Bandung and online from across the world. ladies and gentlemen, a very warm welcome to you all. It is a genuine honor for me to open the second international conference on smart mechatronics. On behalf of the National Research and Innovation Agency and our co-organizer, the Faculty of Industrial Engineering of Telkom University, I welcome each of you to this city we proudly call the Pari of Java. To those who have traveled far to be here in person, and to those joining from your laboratories around the globe, thank you for being part of this. Your presence reflects the borderless community of science that BRIN is proud to belong. This year, we gather around a theme that captures the moment we live in, empowering smart mechatronics innovations, robotics, AI, and intelligent systems for a connected, intelligent world. These are not abstract words. Mechatronics is the discipline that brings mechanical engineering, electronics, control system, and artificial intelligence together into a machine that sense, decide, and act. It is precisely the kind of capability a nation need to solve real problems, and Indonesia has real problems worth solving. Let me be direct about what those are. BRIN has set out a series of strategic research themes for the nations, among them food security, health security, energy security, water security, disaster resilience, labor-intensive industry, and creative economy, and frontier science. A country of more than 270 million people spread across more than 17,000 islands and sitting along the most active seismic belt on Earth cannot import its way to resilience in any of them. It must be built the capacity itself. And this is the striking thing about smart mechatronics. It cuts across nearly every one of these themes. It is not adjacent to our national agenda. It is woven through it. And yeah, this is not distant ambition. Work in this direction is already underway within BRIN across our research in electronic and informatics. For example, consider the food security. Researchers are exploring precision agriculture systems that pair connected sensing with artificial intelligence, irrigation that respond to soil moisture and temperature, and data-guided approach to soil nutrition, so that over time decision in the field can be informed more by data than by guesswork. Consider disaster resilience, where so much is stake for our country. A soft and bio-inspired robot hold real promise for navigating the narrow, unstable void of collapse structure, where it is too dangerous to send a person. And also satellite remote sensing, paired with machine learning, can help turn raw imagery into early warning, comparing condition before and after an event, and supporting faster, better informed response. Consider with the help in soft and continuum robotics, researchers are working toward a surgical system that would one day operate through the smallest of opening. With AI is being explored to support a diagnostic and quality of care. And biomechatronics and assistive technology hold the promise of restoring mobility, independence, and dignity to those who need the most. For energy and water, through the intelligent control, monitoring, and embedded system that can help make infrastructure cleaning and more reliable into mobility, through ongoing work on autonomous electric vehicles, and into the wider effort to add value to our industry and to engage with the frontier of science itself. Allow me to share the conviction guides our works. Research and innovations are not luxury for developing nation. They are its foundations. The evidence is consistent across the world. The higher nation climbs the global innovation index, the higher its prosperity tends to rise with it. Innovation and economic progress move together. Our task at BRIN is turn invention into innovation to consolidate the excellent work already being done across our research institutions and universities so that it delivers real impact. We are committed to serving as nation science-based think tank, to grounding research agenda in genuine needs of user, and to deepening collaboration both horizontally between institutions and vertically with our region. The partnership behind this very conference, BRIN together with Telkom University, is exactly the model we want to see more of national research and leading university working as one. And let me add a word on sovereign is not merely ownership. It is mastery. It is the capacity to design, to build, and to sustain the technology ourselves. Allow me to express sincere appreciations to everyone who has made ICSMech 2026 possible. To our keynote speaker, whose insight elevates this gathering, to our co-organizer, the Faculty of Industrial Engineering of Telkom University, and to IEEE for its technical sponsorship, to the technical committee, reviewers, partners whose dedications is the backbone of this event, and above all, to the authors and presenters. You are the essence of this conference. I also wish to recognize our collaborating academic institution whose involvement give this conference its brand and its nation character. First, Universitas Pendidikan Indonesia, Universitas Pembangunan Nasional Veteran, Universitas Sriwijaya, Bina Nusantara University, Institut Teknologi 10 November, and Universitas Diponegoro. That so many our leading universities stand together behind ICSMech itself, and is a reflection of the consolidated collaborative research ecosystem Indonesia is working to build. My gratitude extend equally to our sponsor and industry partners. Your support is more than generous patronage. It is a vote of confidence in very partnership between research, academia, and industry. And also our international guests, welcome to Indonesia. I hope you will experience with warmth and hospitality in our country. Let ICSMech 2026 be more than an exchange of finding. Let it be a catalyst for new collaborations, for bolder questions, and for innovations that one day reach the people who need it most. With that spirit and with a great optimism for the days ahead, I am pleased to declare the second international conference on smart mechatronics officially open. I wish you all a productive, inspiring, and memorable conference. The knowledge share here, the connection, forge, and ideas ignite, contribute a smarter, more resilient, and more inclusive future for Indonesia and for the world. Wassalamualaikum warahmatullahi wabarakatuh. Thank you. Bandung, 9 Juni 2026, Kepala Badan Riset dan Inovasi Nasional, Profesor Dr. Arif Satria.
Thank you, Professor Dr. Eng Budi Prawara, for that inspiring opening speech and for formally declaring ICSMech 2026 open.
It is an honor to have you with us, and we are deeply grateful for your presence in this morning.
Ladies and gentlemen, ICSMech 2026 is now officially open.
Ladies and gentlemen, before our group photograph, we would like to present a token of appreciation to our value sponsor.
We begin with our silver sponsors. May we invite the representative of Chairman of BRIN, Professor Dr. Eng Budi Prawara, to present the token of appreciation. Please come forward to the stage. Receiving on behalf of our silver sponsors, Pelindo, Unitronic Jaya, and Intechno. Please come forward to the stage. Thank you to our representative. You may now be seated. Please give a round of applause.
Next, our bronze sponsor. May we invite the Dean Research Institute, RICCSL, Asaf Professor Dr. Bambang Setyanugroho, ST, MTech, to present the tokens of appreciation. Please come forward to the stage. Receiving on behalf of our bronze sponsors, Trakindo, PT Star Perkasa Technology, PT Manvis Technology Engineering, PT Rekayasa Hijau Mandiri, Dewesoft, and Mr. Muhammad Nasir Ardiansyah, PhD. Please come forward.
Thank you. And finally, our operational support partners. May we invite the General Chair of ICSMech 2026, Dr. Romi Permana Saputra, to present the token of appreciation. Please come forward to the stage. Receiving on behalf of our operational support partners, BRI and Wuli. Please come forward to the stage. Thank you. You may now be seated again. Please join us in thanking all of our sponsor once more. We now invite our distinguished guests, speakers, and VIPs to the front of the grand ballroom for our official group photograph. Thank you, and please remain in position as we now invite all of our participants to join you for our second photographs.
Ladies and gentlemen, all participants, please come forward and join our distinguished guests for photograph. Participants will come forward and join our distinguished guests. Thank you very much, everyone. What a wonderful photograph. To all participants, thank you for joining us. Please make your way back to your seat. All right, I apologize. Again, all participants, please come forward and join our for photograph.
Thank you very much, everyone. What a wonderful photographs.
We know respectfully invite the representative of the chairman of BRIN, the Dean Research Institute RICC-SL, and our distinguished guests to kindly proceed from the room. You are most welcome to visit the BEST 2026 exhibition or the pre-function area. We kindly request all participants to be seated again by 9:30 a.m. for our keynote session beginning at 9:40 a.m.
Please enjoy your coffee and the company of your fellow delegates.
Please give it a applause.
Faculty of Industrial Engineering at Telkom University is one of the first faculties at Telkom University committed to producing a future generation ready to face the challenges of global industry. We offer excellent study programs with national accreditation as well as several internationally accredited, including Bachelor of Industrial Engineering, Bachelor of Information Systems, Bachelor of Logistics Engineering, Bachelor of Engineering Management, Master of Industrial Engineering, Master of Information Systems. Our faculty acts as a center of innovation in higher education, connected in the Telkom University National Campus Network. With campuses located in major cities like Bandung and Jakarta, we provide a quality education that combines theory with practice, giving students access to a variety of industry opportunities and extensive professional connections. We are supported by expert lecturers and competent support staff, many of whom graduated from renowned universities both domestically and internationally. We also had state-of-the-art academic facilities, such as ProsMed Laboratory, Warehouse Laboratory, Computer Laboratory, with over 22 other laboratories ready to support student learning. We are proud of our achievements of our students who have won prizes in various national and international competitions, such as First place, Gajah Mada International Business Case Competition.
First place, National Nizit Confest 16 Competition.
First place, National Technology Work Competition 2024. Second place, National Creanomic Business Plan Competition. We are ready to face global competition. The Faculty of Industrial Engineering at Telkom University is committed to becoming a national excellent entrepreneurial faculty with international standards by 2028 in the field of information technology-based industrial systems focused on sustainable development. Together, contribute to the world at Telkom University.
Dalam pemenuhan kebutuhan masyarakat, tidak lepas dari kegiatan ekspor melalui penyediaan pelabuhan bertaraf internasional, Pelindo tentunya diharapkan mampu mendukung para pelaku usaha di Indonesia yang ingin memperluas bisnis. Dengan pelayanan yang semakin cepat dan efisien, Pelindo sebagai operator pelabuhan berstandar internasional siap bersinergi menjadi gerbang perekonomian Indonesia untuk dunia.
all participants, please enjoy your coffee break behind the grand room.
The Faculty of Industrial Engineering at Telkom University is one of the first faculties at Telkom University committed to producing a future generation ready to face the challenges of global industry. We offer excellent study programs with national accreditation as well as several internationally accredited, including Bachelor of Industrial Engineering, Bachelor of Information Systems, Bachelor of Logistics Engineering, Bachelor of Engineering Management, Master of Industrial Engineering, Master of Information Systems. Our faculty acts as a center of innovation in higher education, connected in the Telkom University National Campus Network. Campuses are located in major cities like Bandung and Jakarta. We provide a quality education that combines theory with practice, giving students access to a variety of industry opportunities and extensive professional connections. We are supported by expert lecturers and competent support staff, many of whom graduated from renowned universities both domestically and internationally. We also had state-of-the-art academic facilities. such as PROSMED Laboratory, Warehouse Laboratory, Computer Laboratory, with over 22 other laboratories ready to support student learning. We are proud of our achievements of our students who have won prizes in various national and international competitions, such as first place Gajah Mada International Business Case Competition,
First place, National Nizip Confest 16 Competition.
first place National Technology Work Competition 2024, second place National Creanomic Business Plan Competition. We are ready to face global competition. The Faculty of Industrial Engineering at Telkom University is committed to becoming a national excellent entrepreneurial faculty with international standards by 2028 in the field of information technology-based industrial systems focused on sustainable development. Together, contribute to the world at Telkom University.
Dalam pemenuhan kebutuhan masyarakat, tidak lepas dari kegiatan ekspor.
We kindly request all participants to be seated again for our keynote sessions. To all participants, we kindly request to be seated again for our keynote sessions.
We kindly request all participants to be seated again for our keynote session to begin.
Again, to all participants, we kindly request to be seated again for our keynote session. We kindly request all participants to be seated again for our keynote sessions.
Attention, we kindly request all participants to be seated again for our keynote session to begin.
Bapak, Ibu semua, dimohon untuk kembali untuk keynote session.
Attention, we kindly request all participants to be seated again for our keynote session to begin.
Sekali lagi, Bapak, Ibu dimohon untuk kembali ke tempat untuk memulai sesi keynote.
Ladies and gentlemen, welcome back to the Grand Ballroom.
We now move into the academic heart of ICSMech 2026, our keynote address sessions. Our first keynote will be delivered by Professor Michael Milford from the Queensland University of Technology, Australia.
To guide the session, may we now invite to the stage our session moderator, Professor Dr. Hanif Fahruroja, SSE, MT, from BRIN. Please come forward to the stage. Professor Dr. Hanif Fahruroja. He is a researcher professor in PRMC BRIN with expertise in machine learning, big data analytics, and IoT. He is the author of over 160 international publications.
Professor Dr. Hanif, the floor is yours.
Thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good morning, distinguished guests, respected professors, researchers, industry representative, colleagues, and participants. On behalf of the organizing committee of the second International Conference on Smart Mechatronics, ICSMech 2026, it's my great pleasure and honor to serve the moderator in this keynote session. Today, we are privileged to be joined by an international renowned researchers and two leaders whose work has significantly advanced in field of robotics, artificial intelligence, machine learning, and autonomous systems. Allow me to introduce our keynote speaker, Professor Michael Milford from Queensland University of Technology. Please join me welcoming to the stage, Prof. Milford. Thank you. Give applause. Professor Milford conduct interdisciplinary fundamental of applied research at the intersection of robotics, neuroscience, computer vision, and machine learning from 2022 to 2027. He has been leading a major research initiative focused on developing a ubiquitous alternative to GPS that does not rely on satellite infrastructure, combining bio-inspired principle with cutting-edge computer science approaches. His research team has collaborated with leading global companies, including Ford and Caterpillar, and has received funding and research support from prominent organizations such as Amazon, Intel, and Google.
Keynote this morning. Thank you to everyone for attending. Thank you to the volunteers. Thank you to the sponsors as well. So, today I want to share with you some of the research that we've done at my university in robotics and autonomous systems and AI over the years. What I want to do is start by talking about some of the work we've done in what we would call biologically inspired or nature-inspired robotics and automation. And I know at least one of the other distinguished speakers is interested in this area of bio-inspiration as well, which is fantastic. I'll talk a little bit about some of our work translating this research into deployments or work with industry and government partners in the areas of autonomous vehicles, for example. I'll touch on some of the big unsolved problems in research that I think are fantastic opportunities for researchers to study. These are areas that are not solved and that are directly informed by our work with industry. And I'll touch on one of the large, ambitious projects that we're currently working on in the navigation space, including for robotics. So first of all, I want to introduce a little bit about the center that I currently lead, called the QUT Center for Robotics. We are a large robotics research center. We work on robotics projects in just about every domain, so in the skies, on the ground, on the water, deep underwater and deep underground, in areas from agriculture to autonomous vehicles in transport, and a large number of other areas. We work on fundamental blue sky research, but we also work on very applied commercial research as well. We're interested in taking what you develop in the laboratory and turning it into actual useful technology. And I think a lot of the opening comments at this conference really reflect this idea of taking fundamental research and translating it into something that might actually have impact in the real world. To showcase just a few of the areas that we work in, we are part of a major national initiative that works in Antarctica. So our team is working on the drones and submersible robots that are deployed in Antarctica to do things like environmental monitoring. And that team has just got back from its 4th season in Antarctica, operating submersible robots and drones to do things like monitoring lichen. Operating in such a cold and extreme and remote environment is very, very challenging, and you learn a lot about the limits of the technology from trying to operate in such a challenging environment. From one extreme to the other, we work a lot in other areas like marine and ecological robotics. This is probably still our most famous robot. It's called COTSpot. COTS is an acronym. It stands for Crown of Thorns Starfish. That is a little creature you can see at the bottom of the slide. This is a species that is doing great damage to our Great Barrier Reef and other coral reefs. And the traditional method for dealing with this was for divers to manually remove the Crown of Thorns starfish. And so Matt and a number of other researchers in our center developed this COTSpot, which was an automated or semi-automated submersible robot that would inject the Crown of Thorns starfish with a solution which neutralized it in order to try and protect the reef. We got some funding from a number of sources, philanthropy from Google and a number of other sources to develop a fleet of improved versions of this submarine. These are called Ranger bots. And you can see some of the researchers out in the field with these robots, and they're using the Ranger bots to help with aspects of regenerating the coral reef, like the coral reef respawning process, which is how we can regenerate the reef and hopefully restore it to its former glory. So you saw some of the teams operating in Antarctica. We do a lot of work in aerospace robotics. So not just developing the aerial robotics, but also developing the systems that control the aerial robotics. So Professor Aaron McFadden, who you can see in the middle picture, developed some of the drone flight approval systems. So these are the systems that automatically determine where it's safe to operate a drone in the vicinity of an airport. And this is an example of one of the deployed technologies from our center. So this isn't a research lab project. This is technology that is currently in operation at airports that keep the drones away from the passenger aircraft, which is obviously a vital safety requirement. And he's won a large number of awards and is in demand around the world for his expertise in this area. We are very much engaged in artificial intelligence. So robotics and artificial intelligence are two related fields that overlap heavily. This is an example of some of the work that we have done and that many other labs around the world are discovering, which is that with modern artificial intelligence approaches, so large language models, vision language models, and all of these related relatively recent advances, you can make your robots much more capable than they were before. So this is an example where a robot has been instructed to place something healthy on Peter's desk. Traditionally, this is very easy for people to do. We understand what this means, but for a robot to interpret this and understand what it should do is very challenging. And these new AI systems enable the robots to act in a way as if they have some degree of common sense, which means that they are much more capable of understanding sort of casual, informal language like this and responding to it and doing the right thing. In previous years, if you saw a video like this, it would have been mostly scripted or pre-programmed because the state-of-the-art systems back then weren't really capable of doing this. We, of course, are invested heavily in exploring what you can do with humanoid robots. They're probably arguably the biggest technology area in robotics right at this moment. I just got back from a major international conference in Vienna with about 8,700 roboticists, and there were lots and lots of humanoid robots at the conference. This is an example. We took a humanoid robot on its first ever race in Australia. So this is it as it finished. I think the video will play. Finished crossing the finish line on a bike, whatever it is. So lots of interesting research to be done there. We're just starting to scratch the surface. What I did bring is I have these really neat 3D models of this robot, which you can make. And I've got a number up the front, which you're free to take a copy home for yourself or for any family. They're a lot of fun. They take about 10 minutes to make. My particular research group has always been interested in navigation and positioning for autonomous systems of all sorts. We have always been motivated by two primary factors. One is scientific curiosity, because I'm at a university, we can explore ideas that are interesting, and also the problems that industry or government come to us and would like some assistance in solving. We've drawn a lot of inspiration from biology to develop solutions to these problems. And we've also drawn inspiration from what we understand about how our brain and the brain of animals works in solving these problems. Robots still have a lot to learn from nature, and I think you'll hear about that later in this conference as well. We also use AI, lots of artificial intelligence, machine learning techniques, both classical methods and modern techniques. And we typically put these on robots, and the systems almost never work the first time you put them on the robot. They often don't work the second time or the 10th time you put them on the robot. And that's where the real research, development, and innovation occurs, is in working out why the systems aren't working and improving it. And in some cases, when you do this, you learn all sorts of insights that you can feed back to those collaborators who you've been working with across all these different disciplines. My particular research area, as I said, has been in positioning and navigation for autonomous systems. And over the last 2 decades, we've been interested in scaling up the capability of these systems. So working at very precise scales, for example, positioning for surgical robotics, all the way to trying to develop global positioning system alternatives, and working at very fast timescales, so very low latency approaches, all the way to systems that are meant to operate for multiple years in the real world. And as I said before, we work in a lot of application areas as well, where we take what we've learned from the lab and try to work with industry partners or government partners to make this into a useful technological capability. So one of the key areas of research we've done is in what we'd call nature-inspired robot mapping and navigation. This is probably the system I'm still most well known for, which is called RAT-SLAM. SLAM is an acronym in robotics that stands for simultaneous localization and mapping. It's basically the task of if a person or an insect or a robot goes into a new environment, it needs to explore that environment, create a map of that environment, but at the same time, and this is the simultaneous bit, keep track of where it's located in that environment. It's been a classical problem for robotics for about 25 years now. One of the interesting things is if you think about how nature creates mapping and navigation systems for people, for animals, and for insects, it's very different to how most classical robotic systems operate. And so the system on the left is a classical robotic system. It's creating an occupancy grid map of a corridor in a building as a robot moves down it. But we know that animals map and navigate the world very differently. Animals are also very inspiring. So the brown rat, which is a particular type of rat, has only become widely distributed throughout the entire world in the last several hundred years. And it means that the brown rat that you find in this incredibly diverse range of environments around the world has to learn how to navigate and map totally different environments, from a desert to a sewer to an office building to a house. And so this is a degree of generalization or generality that's very impressive, and which is far beyond most current robot systems, which are much more brittle. We know a lot about what animals, people, insects, humans, how they perceive the world, how they sense. We know that rodents, despite having very limited vision, so their vision is sort of a blurry, low intensity view of the world, even just using that vision, they're capable of very impressive tasks. And perhaps most importantly, we know a lot about what is happening inside the brain of people, of animals and insects when they do navigation. So this is an overhead view of a rat as it moves around a small square arena. And there's a little yellow patch that's superimposed on this arena. And this is everywhere in the environment where one particular neuron or cell in the brain fires. It's called a place cell. And it's called a place cell because it only fires when the rat is at a certain place in the environment. Now, there are lots of these types of navigational cells in the brain, and these are most likely also exist in the human brain as well, our brain. And one of the other types is called a head direction cell. So this is a cell that only fires when the rodent's head is orientated in a certain direction. So for a roboticist who is looking to nature, to animals, to humans for inspiration, this is really interesting because we have all the components to build some sort of mapping system for a robot, which is really exciting. And that was how we got started. There are a few challenges here. So we're ultimately interested in developing useful technology for society. So first of all, some of the tech tasks that we would like to develop technologies for example, autonomous vehicles, there aren't exact examples of that in nature because dogs don't drive. Nature is, apart from humans, there are no other animals that drive cars around. So we can't learn directly for that task. We also have amazing technologies in robotics and tech that don't actually exist in the animal kingdom. And so we have, for example, LiDAR range sensors in robotics, which tell the range to objects 200 meters away to within like a centimeter's accuracy. And nature doesn't really have any of these sensors. We would like to leverage and use these sensors as much as possible, especially if we want to create robots that are as safe and reliable as possible. The third challenge is the neuroscientists and biologists who are studying the natural kingdom. They have found and discovered a lot about what happens in nature and what happens in the brain, but we don't know everything. The brain is arguably the most complex thing we have ever studied in the history of humanity, and we're just starting to scratch the surface on understanding how it actually works. So they don't have all the answers yet. So we started modeling this system to create robot mapping and navigation technology. We had to simplify what was known about how the brain did mapping and navigation down to this system on the right. And essentially what we were trying to do is in software on the robot model two types of navigational cell, the place cell and the head direction cell, which between them represent the location and the orientation of the robot, which is useful if you're trying to make a robot navigate around a building. And I saw some interesting robots outside at the exhibition, which I'm hoping to get a closer look at. The type of neural network that we used is a classical neural network. It's called a continuous attractor network, or a CAN. This is the layout of the network. This is a network that is representing the direction or orientation of the robot. Each of the neurons or cells represents a nominal direction of the robot. It has local positive connections and global inhibitory or negative connections. And this is what it looks like if it's fully connected. We used this type of network for two reasons at the time. One was it represented what we observed or what our colleagues observed in the brain in terms of the dynamics of how these networks work. It also works a little bit like a Kalman filter, which is one of the classical approaches to doing robot mapping and navigation, and has been for many, many years. So this is where we started our journey, and we had three challenges. And I'm aware that a lot of the audience is probably relatively early in their research career, so hopefully some of these are particularly relevant to you. So the first challenge was it didn't work. So we put it on a robot and it was moving around in a very small arena, like a 2x2 meter arena with some artificial landmarks. And the system got more and more lost. And the point of a mapping and navigation system is to not get lost. And so this was a problem. And you can see the error building up over time. This is about an hour-long experiment. This is how lost the robot was. And we thought about why this was, and we did a bunch of analysis. And what we worked out was that it was because we had two separate neural networks representing place or location and orientation of the robot. There was no coupling or link between these two separate representations of location and orientation. And that meant there was no way to know which estimate of orientation belonged to which estimate of location. You had a coupling problem. And the result of this was there was no way to independently and correctly update and propagate multiple estimates about where the robot could be and where the robot could be facing. So it was basically a fundamental flaw with the system. The second problem that we faced was that we were getting some pretty critical feedback from our paper reviewers. I'm sure many of you have submitted papers, including to this conference. Sometimes your papers get rejected. We were getting comments that our work was multidisciplinary, but wasn't having any impact in either of the two fields, which was a little confronting at the time, but something we could work on. And the third thing was, at the time, the papers that we were comparing to were amazing. These were the leading researchers in robotics, and they were able to create systems that could create very accurate maps of entire building sort of floor plans. So we felt like we were a very long way behind the state of the art. So we had these three challenges to address. So what we did is we had to make a decision, and our decision was to focus on creating a version of the system that was as performant as possible. So that one that could do as impressive and capable mapping and navigation for robotics as possible. So the system that we came up with, and this is the RATSLAM system I mentioned before, you can see it on the screen, and it has two key innovations compared to that initial model. First of all, we engineered or made up a new type of navigational cell called a pose cell. That is that network on the left that you can see. And these are cells that encode both the location and orientation together. So we've solved that coupling issue. And then in some of the videos you'll see a sort of graphical map being formed, and that's the middle part of this slide. This is called an experience map, and it's a graph-like map representation of what the neural network is learning about the world. One of the really interesting things was about the same time, some amazing neuroscientists who'd been working on this for many, many years discovered a new type of navigational cell in the brain called a grid cell. And a grid cell is something that still amazes me to this day. This is a cell or a neuron in your brain that fires not just when you're at a certain place in the environment, but anywhere on a triangular, tessellating, repeating grid of locations around the environment. And for this discovery, a few years later, the core team of 3 scientists won the Nobel Prize in Medicine and Physiology. And I've had the great honor of meeting all 3 of these scientists and discussing some of our work with them. So what were we able to do with this improved system? And for the younger researchers in the room, I'm obviously summarizing or glossing over years of hard work, years of setbacks, years of problems, years of frustration to get to this point, because it is a summary talk. So one of the things was we were able to do a robot marathon. So this is a robotic mapping and navigation experiment that ran over a course of 2 weeks, where a robot used our system to continually map around 40 kilometers of journey over around 40 hours across 2 office buildings. And it was continually mapping and learning and navigating the environment, which was a pivotal breakthrough at the time. The other experiment we ran was mapping a suburb, and I'll show you in a little bit more detail what that was. So my new employer gave me 2 laptops, MacBook Pros at the time, and I didn't know what to do with them. And so I put them on the roof of my car, and we drove 66 kilometers, about 40 miles around the suburb around my university at the time. And we fed the input from the web camera, the little camera on the laptop, into the RATSLAM system. And this is what popped out. Whoop. So this is the end result of the system. You're not seeing a little behind the scenes, but we were able to create a topologically correct map of the entire suburb using just the camera input that you see at the top left. No GPS, no speedometers or encoders on the wheels, just that input from the camera at 10 hertz. And at the time, this was the largest environment anyone had mapped with a purely visual SLAM system. And so this started to get a lot of attention in the robotics community, and we were able to build upon this. So in the time since then, we've worked on a lot of projects. What we've tried to do is look at all the shortcomings of our system, because all the systems you develop in research are never perfect. They solve one problem, hopefully very well, but they always have limitations. And so we worked on some of the problems. So one of the problems was our system didn't work initially at night, because when you're in a car at night, the world looks very, very different to how it looks during the day. And so with systems like our sequence SLAM system, we're able to help the system recognize that these are actually visually the same places in the environment, even though they look very different to us and to the algorithms. This particular system needed to use a sequence of images in order to pull off this achievement, but we worked on improving that in the future. I'll mention a couple more things, which was, this was submitted, this work, which is probably the most excited I've ever been in my career. We submitted it to one of the top elite computer vision conferences, which is called ICSMech, and we got incredibly negative reviews, and the reviewers had to select an option about how they felt about the paper, and 2 of the 3 reviewers selected the option which said, I would be very disappointed were this paper to be accepted. They've since improved the reviewing process, but this isn't very motivating when you're a PhD student or an early career researcher. And so it went on to win the best robot vision paper at ICRA. That's that major conference the same year. It was the same paper, we just resubmitted it essentially. And it was also a best paper finalist at one of the other leading robotics conferences. So you can go from a very harsh rejection to a really nice outcome in a surprisingly short period of time. So if you get rejected with your papers, don't let it depress you too much. And we eventually went back to the computer vision community. We published a key paper in CVPR, which is another top computer vision conference, where we were able to now do this same task, but using just a single image. So we didn't need long sequences of data, which made it much more practically useful. And we've done a huge amount of work since then, which we're very proud of. Just to highlight one example of this, we've continued the work in nature and neurally inspired robot mapping and navigation, and we've worked on more hardware-based systems. So there's a field of research called neuromorphic computing, and so these are computer processing units that model not traditional neural networks, but actually spiking neural networks. These are neurons that spike and have activity. And these are a little bit closer to how we think the brain actually works, as well as using innovative sensors like event cameras. So you can see an event camera feed at the top right of this slide. I'll just go back and see if I can play it again. And it sees change in the image. So it works very differently to conventional cameras. And you can read about some of this work. We had a nice paper in Science Robotics last year. And last week, one of our students, Vignesh, presented some of the work with event cameras at this ICRA conference. People often ask me, like, are your systems that you develop, the more applied ones, are they fully based on biology? So I always present this picture. So this is a breakdown of what typically goes into one of our systems. So it is varying combinations of 3 components. One is biological inspiration. The second one is what we'd call classical mathematical approaches to the task. And the third one involves AI and machine learning. And the proportions of which one of these were used depends on a whole bunch of factors, and some of the factors are listed on the right of the slide. I won't spend much time going into those. But what is really interesting is that the biologically inspired work that we do always influences the other 2 components of the systems. So to give you one example of this, Sequence SLAM, which is our top-cited work, it has well over 1,000 citations. It won all these awards and a lot of grant funding money to progress the work further. It was initially created as a happy accident of us working on modeling biological spiking neural networks. And it was a happy byproduct of this algorithmic breakthrough to create the Sequence SLAM system. All right, so that's just a little bit of a high-level taster of a little bit of the research that we've done in our group over the years. I want to talk a little bit about translation. And just to follow on the opening remarks. So sovereign capacity in robotics and automation to help with continuing to improve productivity, quality of life is a critical existential task, problem, and opportunity at the same time for most countries around the world. Australia is talking about this a lot as well. This was very interesting to hear the opening comments this morning. Creating research breakthroughs are really hard to do. Harder still is to create proof of concepts or pilot trials or experiments with the research with an industry partner or government partner, but infinitely harder than either of those two things, which you probably think is already quite challenging, is creating robotic technology that actually makes it into enduring deployment in the real world. So not a proof of concept, not a pilot study, those are still valuable, but going from that step to something that millions of people use every day is the hardest thing, in my opinion, to do in all of research. It is incredibly difficult and it happens incredibly rarely. So it's something that's very important, but is very difficult. So I want to show you some examples of work which has had varying levels of translation in a range of areas, particularly in autonomous vehicles. So this is work we did with Caterpillar and a number of other partners. It was interesting to see Caterpillar, the local Caterpillar dealer, is one of the sponsors of this conference. So we were working on improving the positioning and navigation systems for underground load haul dump, or LHD, load haul dump trucks, which operate deep underground. So you can see a video. This is actually, I'll go back a slide. Oh, no, yeah, you can see a video of what the truck is doing in the middle. And this is showing one of our experiments. We went to a number of underground mine sites, and you can see the vehicle working out and keeping track of where it's positioned underground. This is up to 600 meters deep underground on a 5 to 10 kilometer journey. So developing a couple of positioning systems for that company. We also work with government. So we had a 3-hour drive from Jakarta to here last night, and I was talking to everyone else in the car about whether there was autonomous vehicles yet in Indonesia. And so one of the things we've done a lot of work with is with government to help government make good decisions about when they should consider introducing autonomous vehicles and what the current capabilities of autonomous vehicles would be on our specific roads. And Indonesia has its own local traffic conditions, just like Australia does. These are often different to where the cars are primarily developed, which is places like California, for example. As I said before, it's not just autonomous vehicles. We work on positioning systems for other areas. So this is a project, a surgical robotics project. One of the key tasks in shoulder joint replacement surgery is to position a guide wire as midway through the surgery very precisely in terms of location and orientation. And so we were developing systems that could do this, but we were making the systems introspective. And I'll talk about why I think that's important. Basically, a surgeon watching the robot cannot immediately tell if the robot is doing a good job or a bad job because the difference is so small. So it's not visually apparent. So the system needs to be able to report itself on whether it thinks it's doing a good job. And so we would call this introspection for robotic systems. And finally, more work in the autonomous vehicle space with companies like Ford, working on a variety of different approaches to positioning for vehicles and autonomous vehicles. One of the projects we're most excited about is we are one small part of a major consortium in Australia called the ELO2 consortium, which is building Ruva. Ruva is the name for Australia's first ever lunar rover, which we're all working on, that will go to the moon probably early in the 2030s. And our responsibility in that project is to work on some of the navigation and positioning systems for the lunar rover, which is really, really exciting. Developing, just like working in Antarctica is challenging, developing a system that can work on the moon with limited computer power, no GPS, is obviously very, very challenging. All right. For the final part of my talk, what I want to do is I want to highlight some of the key opportunities and challenges in research that I see that have a lot of room to explore. So if you look at a top robotics or computer vision or AI conference, a lot of the work you'll see is essentially trying to improve performance on benchmark data sets or benchmark tasks, trying to get an extra 1% of performance out, and that might be acceptable. In all the work we've done with government and industry, what we've discovered is there's probably a whole bunch of changes to how we conduct research as a field, and I want to give you 3 examples of this. Context of the project, which are discussion for the rest of the conference. All right. So the first one is all errors and sensors are not equal. So I showed you before this video of the mining truck in the mine site. This is the one where you need to restart it. Probably at about slide 50-ish, please. Oh, well done. So this is an overhead view of the tunnels that these trucks operate in. So these are long, narrow tunnels. This is a large truck. It could weigh 10, 20 tons. And you are interested in the positional error of where that truck is located. Now, not all positional errors matter the same. So one error is the lateral error. This is the error in how far sideways the truck is in the tunnel. If you get that error, if that error is too big, what's going to happen? Well, the truck is going to hit the wall of the tunnel. That might damage the truck. Even worse, it might just shut down operations in that part of the mine for several days, even. And so that type of the longitude error, this is the error in the position estimate along the direction of travel along the tunnel. For a lot of the time, because the tunnel is long and fairly featureless, it doesn't matter if that error is a few meters. It matters when you approach the end of the tunnel, and it matters when you need to make a critical turn. So different errors matter different amounts at different times doing a robotic task. Not only that, the different sensors you have, most robots have multiple sensors, they have different error distributions or estimate distributions. So this is an overhead view of the estimate of position of the vehicle based on the different sensors. So you can see that the camera sensor, which is in the middle, its distribution of estimates about where it is, it's a bit chunkier. It's not as constrained laterally, whereas the LiDAR or laser update on the left is much narrower because the laser is able to explicitly detect how far away the tunnel walls are. And so it's not just that different errors matter, but it's also sensors give you different distributions for estimates. And so this is not really taken into account explicitly. A lot of research, I think, could do a better job of this. Another one is with better metrics. So if you look at most papers published in robotics and machine learning and computer vision, they're basically comes down to one or two key or performances that are reported on. Again, example, reliable or safe your system is. So we think we need better and more sophisticated metrics to report on. This is an example. I'm going to give you 2 scenarios to pick from. Imagine you're the CEO of a $1 billion autonomous vehicle company, and you've got to make a decision of which positioning system to go with. When you see the vehicle move, blue means the vehicle is well positioned or localized, and red means it's not. And these 2 scenarios have identical global performance. So in a paper, these would be reported as performing the same. But let me know which car you would rather have operating in life and death critical situations. So this is scenario 1, well localized. Well localized. So that's the distribution of when the car knew where it was and when it didn't. This is scenario number 1. All right. This is scenario number 2. So this has the same global performance as the first one. Which of the scenarios would you prefer to have operating around you? Scenario 1 or scenario 2? So most people would say scenario 2, and it's for 2 reasons. One is when the car is lost, it's lost for a much shorter period of time, and there are ways to compensate for that. Those methods to compensate for it usually get worse over time. So short periods of being lost are good. The other factor is where in the environment the car is lost. And so safety critical situations are things like approaching a pedestrian crossing. You want to be especially certain of how your navigation, 1/10 the time of system 1. And so this is what we call introspection. Does the system have the ability to assess its own performance and report when it's probably not working? And this relates to a bunch of topics that you'll hear about, especially when we're trying to make robotic systems actually as safe and deployable in the real world. Integrity, auditability, explainability, trusted autonomy, these terms are all different, but all relate to this characteristic of introspection. And we've done a lot of work in this space to improve techniques. And why is knowing when you don't know important? Well, the robot can ask for help. The robot can operate a fail-safe behavior. It has a bunch of fallback options, but it has to know that it's in trouble first.
2 minutes left.
Okay. And there's lots of examples of how we've used this, again, in surgical robotics and other areas as well. So just to wrap up with a couple of things. One is, if you're interested in any of the stuff in this talk, just search us online. We have material on all of this research. If you are an early career researcher and you're interested in a resource for helping with your career, I run a resource called Hacking Academia. If you just Google it, you'll find it. It has around 65 or 67 videos, tutorials, and podcasts on everything you need to know to have a successful career in research. And finally, I'll leave you with a video of our local positioning system, which is our attempt to create a global alternative to GPS, building on all the research we've done over 2 decades. And a big thank you to all of our sponsors. So I'll leave you with this video and then I'll take questions. Should be some audio. Thank you very much.
Okay, thank you very much, Prof. Milford, for insightful and inspiring presentation. We have 10 minutes to Q&A session. Maybe from the floor, have any question? Prof. Milford has provided us with valuable perspective on the future of autonomous system, particularly regarding perception, localization, safety, and effective human-robot collaboration. From the natural inspiration, Prof. Milford successful to develop autonomous vehicle. Maybe any question from the floor? Okay, Dr. Salamat, please give mic to Dr. Slamet. Okay. First question, Dr. Slamet, and then second, please state your name, affiliation, and please focus on question. Thank you.
Thank you. My name Slamet. Okay. My name is Slamet Supriyadi. So my research is about GNS application or GPS. Yes, in civil aviation. Yeah, so in your slide, you show that you have drone landing, maybe it's a landing and there's a landing site there. So it's very interesting actually when today in civil aviation we face radio frequency interference science like jamming and spoofing, something like that. So there's an in ICAO or International Civil Aviation Organization, we find an alternative for PNT because there's a vulnerable in GPS. I wonder, is there's any activity in your collaboration with your government, your DGCA or Civil Aviation Director General? Is there any activity in civil aviation? And so not only using drone, but real world in aircraft, because there's so many requirements there. The second one is about the endurance. If we compare within GPS, so it's been good maintenance in anyway. How about using computer vision? If we compare between these tools, which better in endurance? I mean, how long did we realize that it start to degrade? And the third questions is about in your slide or maybe your papers, because this year's the International Conference on Robotic and Autonomy, there's now shift to robot meets GNSS, but in your papers, it seemed like to deliberately working without GNSS. So if we compare between three options, using only computer vision, second one only GNSS, and third one we just using fusion.
Yeah.
If we compare between these two, can you explain it? Thank you.
All right, thank you for your question. What I'll try and do is briefly answer at least bits of all three questions in the same answer. So I guess broadly speaking, everyone around the world, as you know, is very interested in finding redundant, alternative backup solutions to GNSS for a variety of reasons. We know that jamming and spoofing are bigger and bigger challenges today. There are also natural phenomena that can interfere with GPS. And of course, GPS doesn't work indoors or underground, which is there's a large variety of applications. I think what I've seen in response to your last question is that people used to be saying GNSS is the best solution or robotic SLAM is the best solution. Obviously, none of those solutions by themselves are completely reliable under all situations. And so I think we've seen a maturing of the approach to we need a multimodal approach that integrates varying degrees of each of those different solutions. So inertial solutions, GNSS solutions, map-based solutions, and so forth. And then the trick, which is still an open area of investigation, is how do you automatically weight and fuse between those different systems depending on the situation. One massive open opportunity already is that very few systems worked in what we call mixed environments. So the basic act of walking outdoors to indoors will break a lot of current positioning systems in each direction. And so we think there's a lot of integration work probably doesn't really sell that there's a lot of research involved in it, but we think there's a lot of deep research that needs to be done to both improve the individual techniques, but also better automatically integrate them together. And I'm happy to chat more about the rest of it offline.
Okay, thank you for the insightful question and responsive complete from Professor Milford. Continue to second question, please.
Yeah, hello,
on the question.
Michael. This is Professor Shah from Yuanzi University, Taiwan. My question is about the environmental dynamics inside the system. And the second thing is, because I'm working on robots, the same, but it's robot manipulator arm, and it's quite hard to, when the environment is changing, it's quite hard to reach the target object and pick the target object in my case. The second one is, what are the current approaches? Because I missed the starting, unfortunately. So what are the current approaches you are using in your lab?
Sure. So I guess the general question is, the world is always changing, and the way in which the world changes is infinite. So it can be appearance change, it can be geometric change. Much of the world is formable, so it's squishy, and we'll hear about that later in the conference. I guess I'd class the ways in which we deal with those problems into two broad categories. One would be explicit approaches, and one would be implicit approaches. So the explicit approaches, for example, we've done approaches that, rather than try to learn about the way in which the environment changes, actually explicitly models the physics of how change occurs. For example, lighting changes. We would actually explicitly build our current understanding of physics into some of the models. So we have an ICSMech paper, a computer vision paper from a few years back on that. The other approach is to just hit it with the big learning hammer, which, despite being not as satisfying, is very effective. And so if you're in a situation where you can either get enough data that is representative of the types of change, or you can simulate it in a high throughput simulation environment, we would use a lot of learning-based approaches. And again, same as my answer to the which positioning system, obviously neither of those approaches, the explicit or the implicit approaches, are fully reliable by themselves. And so for practical applications, we would combine them together as much as possible. And the weighting of which ones we use would depend on the specifics of the task, the end user, the constraints, the amount of data, how safety critical the task is, or whether you're allowed to fail 1 in 10 times. We take all of those into account.
Okay, thank you for engaging discussion. Maybe we have 2 minutes again. A last question from the floor. Okay, please focus on your question and introducing your name and affiliation. Okay, the last question for this keynote session.
Check. Test.
Introduce your name and affiliation.
Thank you. My name is Tahir. I'm from Trenco company that sell also AI device. I have a question.
Sorry, can you repeat your question? Because
is there an AI-based or smart mechatronic solution for real-time adaptive traffic light control? Signal time is dynamically adjusted according to vehicle.
So I'll paraphrase the microphone cut out, but I think it was real-time response, dynamic adaptation of traffic signals for traffic control. Was that the broad?
Yeah, because it's a problem for the queue system in my place, especially in one-way road. If there is traffic light only red, maybe 10 minutes, 15 minutes. It's different other side with not so many car queue. Yeah? Is there any system?
So my experience in my group doesn't directly work in traffic, but one of the areas where there has been a lot of interest and discussion is if you assume that there is a reasonable percentage of autonomous vehicles on the road, what you'll have in effect is near real-time monitoring in a much richer multimodal way of the traffic situation around traffic lights and in road networks. And one of the areas that we've had a number of conversations about is using that much richer multimodal data that is from the entire network rather than just from the intersections in order to do whole ecosystem traffic planning and optimization. But we haven't personally done much work in that area. One of the colleagues I'm working with is currently using drones to monitor heavy vehicles, for example, but it's all just starting. We haven't finished any work yet.
Okay, thank you very much for the discussion. Because the time is up, I think it's interesting discussion and inspiring keynote from the Professor Milford.
And don't forget to come get one of these.
Okay. Ladies and gentlemen, as we conclude the keynote session, we have gained valuable insight into the future of autonomous system. Professor Milford highlight that successful autonomy is not only about achieving higher performance, but also about ensuring safety, trustworthiness, introspection, and effective human-machine collaboration. On behalf of the organizing committee of ICSMech 2026, I would like to express our sincere gratitude to Professor Michael Milford for his inspiring and talk presentation. Ladies and gentlemen, please join me in giving a warm round of applause for Professor Milford. Thank you once again, Prof. Milford. Thank you. With that, I would like to hand the session back to Master of Ceremony. Thank you.
Thank you very much, Professor Milford, for that excellent keynote. And thank you to our moderator, Professor Dr. Hanif, for guiding the session.
To express our appreciation, we would like to present a token of appreciation to Professor Milford and Professor Hanif.
May we invite a representative of BRIN to present the plaque. Professor Dr. Eng Budi Prawara, please come forward to the stage.
Ladies and gentlemen, our second keynote will be delivered by Professor Yoga Dharma Setiawan of PT Land Industri Persero Indonesia.
To guide this session, may we now invite to the stage our session moderator, Ms. Widya Febriani, SCOM MCOM from Telkom University. Please come forward to the stage. Ms. Widya Febrianti is a distinguished lecturer at the Department of Information System, Telkom University, whose research spans digital transformation, IT governance, data governance, and enterprise systems.
Miss Vidya Febriani, the floor is yours.
Thank you, MC. Okay, good morning, everyone. Yeah, distinguished delegate and our colleagues, and also ladies and gentlemen. Welcome to the plenary session of the Second International Conference on Smart Mechatronics, ICSMech 2026. I'm Vidya Febriani, and it's my absolute to honor serve as your moderator for this session. And we will delve to a strategic, highly relevant topic. And we have this session, we'll explore how the integration of academic and research about the autonomous system innovation or different industry can drive our nation toward the global. So, to guide us to this topic, we have a privilege to have outstanding expert and practitioner in robotic, automation, and defense technology. Please allow me to read a brief profile of our keynote speakers. He is Prof. Dr. Yoga Dharma Setiawan. Good morning, Prof. And the President Director of Veteran Industry Persero. And we have Scientific Officer PT Solusi Teknologi Automasi Robotika. And please give applause for Professor Yoga. Yeah, okay, Prof. And the time is yours.
How many minutes? 30 minutes. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Good morning, professors, distinguished guests, all participants, ladies and gentlemen. My name is Yoga Dharma Setiawan. I used to be the university lecturer, professor. This is very good for me to be here. I remember in Yogyakarta. Welcome. I knew him quite some time, and many others in the participants. Thank you very much for joining, for attending this conference. I would like to share my experience or my perspective about smart mechatronics based on industrial world point of view, or at least from my company perspective. This is the okay. The distinguished guests. If you want to visit the company, we'll see if you have time. We open to you to visit. Today I will. Okay, the slide not yet. Okay, I will share a little bit about the company profile, PT Land Industry. Basically, PT Land is initially was a research kind of institution. Initially in 1965, focusing. Okay, this is the proof that I submitted two papers with my student to the first international conference in Yogyakarta, and unfortunately I couldn't attend. I missed the first conference. Next, I will share my company point of view about how we should be advancing the national technology for sovereignty because under this new government, the Indonesian government wants more manufacture in Indonesia. It is quite for some time. My company was working only focusing as integrator of electronic systems from international products, from foreign products. Next. So I will briefly share our company, what we are doing, what we have done, and we can see the profile of our company next. So land industry is an institution initially for research in electronics. Electronics in 1965, and then starting 2002, it became a state-owned enterprise. State-owned enterprise and becomes a company, and then in 2022 becomes the holding of defense industry in Indonesia. In 2025, now managed under Danantara Sovereign Wealth Fund. When PT Land became the state-owned enterprise, we have the subsidiaries, and we focus on several business lines. We call it Land Incorporated. That means organic subsidiaries of PT Land include the projects, include the defense and security, and in transportation and navigation systems, renewable and sustainable energy systems, and then also public services and protection. Next. In 2022, PT Land becomes the holding of defense industry that consists of 4 other big companies under land management, such as PTDI, Dirgantara Indonesia, which is focusing on aerospace platforms, and then PT Pindad, focusing on land platform, weapon, munitions, and heavy equipments. And then also PT PAL, focusing on naval platforms, shipbuilding, and other maintenance repair for ships products. And then the last one is PT Dahana, focusing on producing energetic materials. Next. In total, under this defense holding company, we call it Defense ID, there are around 10,000 employees, 20 companies, 7 manufacturing plants, and then they are located in Java Island, the headquarters in the city, Bandung, and then there are several other places of the manufacturing plants. For example, for the PT PAL, for the Navy shipyard building company PT PAL in Surabaya and around, and then also several other locations in Subang, and then the yellow color means that's the future location for expansion for manufacturing. Next. I would like to be focusing on PT Land itself, what we have done. What we have done in defense and security systems, such as integrating sensors and surveillance systems, radar system, satellite systems, electric vehicles, command and control system, defense system integration for Navy ships. In the renewable energy system, we produce solar panels, we integrate solar panel plants, and also solar system for telecommunication tower system. In transportation system, we support the railway system, signaling system, and urban railway systems. For public service and protection, we support the integration of weather station, seismic monitoring system, and mobile command centers. Next. We have facilities in Bandung, basically for electronic works, and now being developed in Subang for National Radar Manufacturing Center. Next. Our companies already has many awards and certificates. I think I will skip this. Next. What I would like to share here is what I call for the smart mechatronics system, how we feel or perceive the way we need to work in order to be successful in this industry. We see the emerging and trending technology in smart mechatronics that can be named as cyber physical architecture stack. The first layer is the physical foundation that includes the components, advanced actuators, electrified hardware, modular platforms, and in this era, they need to be reconfigurable, energy efficient, and need to be able to do the mechanical execution efficiently. And then the second layer is the nervous system, which is the connectivity, such as the industrial, and then enable autonomous decision. This time, we feel like to develop smart mechatronic products, it requires two things. First, the engineers who knows very well in the hardware, the physical things, software. So we realize that more and more products, what is called, for example, software-defined radio, software-defined car, software-defined satellite, everything more and more towards software-defined. So when we design a products, we have to be aware from the beginning, the product should be at least software-defined product. And then now more moving to AI-defined product. From the beginning, we have to think that the product should be accommodating AI software changing that usually will be updated continuously, while the hardware part will be updated, can be maybe 1 year, 2 year, slow update. That's why we need more engineers in the software side. Next. In terms of the strategic alignment with the global trends and national policy, or the defense ID get the national assignment to develop, I think we hear about right now 11 key technologies. For PT Land, we are assigned to develop our own radar, military satellites, underwater sensing systems. And then the subsidiary, PTDI, for the aerospace platforms, PINDAT for the land platforms, you can see in the slides. I will not mention one by one. How we approach this assignment to make sure our company can move forward in this industrialization, in which in the past we focus too much on the integration. Next, for the land industry, we have the technology mastery or flagship products. We identify eight strategic technologies that we need to develop. First is artificial intelligence, second, semiconductor, and then communication, military standard communication, tactical detailing, radar and electronic warfare system, satellite and remote sensing technologies, electro-optic and sensor technologies, robotic automation, and cyber securities. This initiative, the technology we are developing, and then we hope in soon we will have the manufacturing plans for each of these. For semiconductor, I just came back last week from the Taiwan ecosystems industries. We will be focusing more in the chip design, not on the manufacturing yet. It is still for long-term goal. But I think it will be very, very attractive business on the chip design. And it will be very, very AI oriented mind from the beginning when we do this, when we start this project. Next, we see the AI, cybersecurity are very important in all of our products. So from very beginning, we have to have in mind this system need to accommodate the AI cybersecurities. For example, for the command control system, radar electronic warfare systems, satellites, electro-optic and sensor system, and then also for robotic and automation system. Next. How can we can see the more detail, the difference between the hardware part and the software part or the system part. From this slide, we can see not divergent philosophy. I think the concurrent philosophy. So there is parallel domain, physical domain, and the cyber domain we need to consider at the same time. If we see the physical domain, I already mentioned before, usually the product will be updated slowly. Yeah. But it requires the system to be correct right from the beginning. Because if we modify later, then it will be too costly. But for the cyber domain, the digital part or the software part, we can do the revision, updates continuously. So the mind of engineers who design the hardware need to make sure they are very, very careful from beginning. They have to, the product need to go through certification, testing, with schedules, not so fast, takes time. But for the software, can be the engineers need to be brave to try to do the change, the algorithm continuously. Otherwise, the product will be, if the mind of the programmer, the IT engineers, the same as the hardware engineers, then the products will be very slow to get into the market. So there are two way of thinking in engineers as the hardware engineer, physical engineers, or the software engineers. So we have to handle differently these two domains. I think I will not explain more. I think it already represent my company idea in how the trends right now in the smart mechatronic system products this time. Next. Before. Next. We see the product life cycle phase from ideation, development, introduction, growth, maturity, and decline retirement. We identify this physical product and the digital product or the cyber domain. The life cycle of physical product usually linear and then stage gated, while the digital product very iterative. We update continuously. That's why more engineers needed to work on digital or cyber domain. The methodology we use in physical product, waterfall, state gate, V model, while in the digital or cyber domain, the methodology must be agile, DevOps, and then we see for the hardware part, at the beginning, the load or the cost of investment will be high. And then for the digital product, at the beginning, the investment usually low. And then after we get the product cost depends on how many units of hardware. While for the software, the cost getting diminished, almost zero for the second, third, and so on. So these are the nature of these two things for the smart mechatronics products. Okay, next. We are using, we are start adopting new tools for the development, what is called model-based system engineering software, and then also product life cycle management. This is used to make sure the collaboration between engineers across domain, physical, and then cyber, between companies, between departments, will run smoothly. We started using these tools this year for our products. The MBSE, model-based system engineering, basically, instead of using document-based in the past, now it use the model to make sure when we are working on the development stage, the requirement analysis, high-level design from the beginning, and then at the end, system testing and integration testing, the upper layer of the V methodology for engineering development can be easily run or perform with strong collaboration between companies, between division. For the detailed design, unit testing, implementation, we already, I think everybody knows, this is what usually academicians focus on. The researcher working more on the detailed design, unit testing, implementation, but for industry, we need to make sure the collaboration between engineers, between the division, between different companies from the beginning, focus not on the document based, but what we call model based. Next. This is an example of our products. One of the product that we have several prototypes, small drones, and then some of them now going to scale up. We are going to build the manufacturing facilities. And then we use this model-based system engineering tool, and then also the product lifecycle tools. Next. We are very interested to collaborate more with the researchers. We already collaborate with BRIN in several projects. We already work with several universities in Indonesia. These are examples. Started last year, we had already 9 research topics sponsored by Indonesian Research and Higher Education Directorate General Ristek Dikti. And this year we have more research collaboration with universities. We have 6 topics, 2 in semiconductor, 4 in artificial intelligence, and so on. We hope we can collaborate more with international research institution, international university. We are open for collaboration. We hope we have more work with friends from Japan, from Turkey, from Russia, from China, and Taiwan. We are open, and then now we are still in progress to collaborate in research, such as we can make sure our products can compete in the global market. And then we think using the model-based system engineering is the way to make the collaboration perform or run smoothly. So we recommend for friends from Indonesia to start learning using this model-based system engineering, or BRIN also, the research institution, so we can collaborate stronger in the future. Okay, that's my presentation. Thank you very much. I'll be happy to answer if there are any questions. Thank you.
Yeah, thank you very much, Prof. Yoga, from highly accurate material and response. So we now have exactly 10 minutes for the Q&A session. And also it's being conducted on hybrid format. So I'm please open to you to have question. If you have question, please raise hand. And also can send the question in chat box maybe. Yeah. So the first question, anyone? You have question? Maybe in the room or in Zoom meeting? Yeah. Yeah. Okay.
Okay, I will say thank you for Prof. Juga. I want to ask about in PT Land, holding of Devon ID. Before Prof says PT Land has established 16 collaboration program with university, research institution, and international partner. I want to ask how does PT Land leverage this national and international collaboration to accelerate innovation and strengthen technological capability in this different sector? Thank you, Prof. Juga.
Okay, I think that's a good question. I would like to share my experience. Quite some time, the defense industry in Indonesia did not do the research well. The research was done only during the Habibie era. And then quite sometimes the research was not done. And now we are, what I say, we don't have enough researchers in the defense ID. So we are trying to manage to have what we call open innovation. So we need to have in each company, they need a PIC. We require to have a PIC person in charge to manage collaboration externally. Make sure they experience already how to manage collaboration in research nationally, internationally, and they need to make sure we participate to get fundings from external sources. This is the example. And then we do it for all our subsidiaries. I hope this way we can really manage well the research collaboration. That's one thing. The second thing, we accelerate the education, the resources, the human resources to get more degree. Used to be the defense ID had a lot of PhDs. Now the PhDs are working outside the countries. Now we want more PhDs working in our company. We send them to get scholarship. So hopefully they can come back. We have more projects to attract them to work on research. I think these two strategy we do to get more research work and collaboration in defense ID. Thank you.
Thank you, Mr. Prof. juga.
Okay, next question, maybe? In Zoom meeting? Or in here, in the venue? Any question? Okay. Sorry. Please, for me. Yeah.
Thank you, Prof. Yoga, for your interesting and impressive presentations. So, yeah, I would like to ask you regarding the development cycle in PT Land. How long usually the development cycle from design to be we can have the such as a product that are ready to be implemented. And you mentioned that it is for the development of products, we have hardware and software. On hardware, we need high cost, yeah, and for software, maybe the cost will be lower than hardware. So, what is your suggestion, yeah, for regarding the collaboration with PT Land, which part that will be sweet for the external party on academici or research institutions, yeah. And I thought that PT Land only developed the yeah,
only for civil image.
Thank you, Prof. Budi Prawara. What we think, for example, from BRIN as a research institution, BRIN already has many experts for the specific fields, for robotics, for radar, for many other things. So for us, we need to prepare the team to support the work in AI, the communication system, to make sure the layer 2 and layer 3. Because to prepare more engineers to work, to be expert in the layer 1, we think it will take quite some time. So we hope it will accelerate to get the development of the product, and then will be useful to the market. Thank you.
Okay, thank you, Prof. Yoga. Maybe the last question from Zoom meeting from Bapak Periadi, student of Doctoral Informasi Telkom University. So the question is based on the slide, understanding the complexity of hybrid CPS domain and how you can engineer design a rigid and 30-year physical hardware platform that remain capable of supporting the computational sensor demands of continuous weekly software evolution without becoming permanently obsolete. Yeah.
The first question is, okay, let me see again. From Priyadi, doctoral student from Telkom University. Basically, how can engineer design a rigid 30-year physical hardware platform remains capable supporting operational and continuously weekly software? Okay. Supporting the computationally and sensory demands of continuous weekly software evolution. Okay, so basically for the layer 2 and layer 3 actually include the sensors and the actuator, but the platform itself, what I mean is the mechanical platform, the thermal platform, the aerodynamic platform, fluid platform, for example, they are usually slow-moving update or revision. So for the sensor part, the computational part, the controller part, for example, and the actuators that can be little bit faster, but the software part need to be revised faster. But I would like to add also, we think the AI engineers, the IT engineers need to know standard minimum model of the system they're working on. Otherwise, it will be dangerous engineers also. So, but they do not need to be very deep in that field, because it will take a long time to make them expert in the specific field. They need some standard knowledge that before they work on a specific project. Okay.
Yeah, thank you, Prof. Yoga. The distinguished delegate, as our time is elapsed, we must conduct the engine session. I apologize the worst question what cannot accommodate today. And today discourse has a particular highlight the technology sovereignly relies on strong synergy between academic research and industrial capacity. The advance by petroleum industry prove that our mechatronic ecosystem is truly ready for the global stage. And please give applause for Dr. Yoga Dharma Setiawan. And thank you, bro. Yeah. Thank you all participants on site and also online for your active engagement. I am Widya and I'm concluding my duties as moderator, and I now hand the floor back to our Master of Ceremony. Thank you.
Thank you. Ladies and gentlemen, to express our appreciation, we would like to present a token of appreciation to Professor Juga and Miss Widya. Professor Juga, please kindly return to the stage.
May we invite a representative of Telkom University to present the plaque, Mr. Muharman Lubis, PhD. Please come forward to the stage. Once again, thank you, Professor Yoga, for the insightful keynote. And thank you to our moderator, Ms. Widya Febriani, for guiding the session. Ladies and gentlemen, we would like to extend our deepest gratitude to our value sponsor.
As part of the support for this event, Wuling is thrilled to showcase their newest car for all of us today. We have an exclusive opportunity. Wuling Motors is offering exclusive drive test experience for two of their outstanding models, the Wuling Darion and Wuling Axion. We warmly invite all of you to come forward and enjoy the ride, courtesy of Wuling Motors.
Also like to express our sincere appreciation to another inclusive sponsor who has made this event possible, Bank Rakyat Indonesia, BRI, and all the sponsors. You can visit their booth out the ballroom. We would like to present a token of appreciation to our value sponsor, PT Star Perkasa Technology. We invite the chairman of the ICSMech 2026, Dr. Roni Permana, to the stage.
Ladies and gentlemen, we have now completed our two remarkable keynote address sessions for the morning. I am certain that we all have been deeply inspired by the world-class insight shared by our distinguished guests.
It is now time for a well-deserved networking luncheon. All delegates, Organizing committee members and invite guests are warmly invited to the grand ballroom dining area for lunch.
We encourage you to take this wonderful opportunity to connect with your fellow researchers, exchange ideas, and explore potential collaboration by building the kinds of lasting partnership that so often begin at gathering like this one.
Lunch will be served until 1 p.m., after which we will reconvene in the grand ballroom for our plenary session, expert panel Q&A beginning at 1 p.m.
Please enjoy your lunch.
Bon appetit,
Itadakimasu,
cuk ngon mieng,
and
selamat makan.
makan.
Competition 2024. Second place, National Creanomic Business Plan Competition. We are ready to face global competition. The Faculty of Industrial Engineering at Telkom University is committed to becoming a national excellent entrepreneurial faculty with international standards by 2028 in the field of information technology-based industrial systems focused on sustainable development. Together, contribute to the world at Telkom University.
Dalam pemenuhan kebutuhan masyarakat, tidak lepas dari kegiatan ekspor melalui penyediaan pelabuhan bertaraf internasional, pelindung tentunya diharapkan mampu mendukung para pelaku usaha di Indonesia yang ingin memperluas bisnis. Dengan pelayanan yang semakin cepat dan efisien, pelindung sebagai operator pelabuhan berstandar internasional siap bersinergi menjadi gerbang perekonomian Indonesia untuk dunia.
Faculty of Industrial Engineering at Telkom University is one of the first faculties at Telkom University committed to producing a future generation ready to face the challenges of global industry. We offer excellent study programs with national accreditation as well as several internationally accredited, including Bachelor of Industrial Engineering, Bachelor of Information Systems, Bachelor of Logistics Engineering, Bachelor of Engineering Management, Master of Industrial Engineering, Master of Information Systems. Our faculty acts as a center of innovation and higher education connected in the Telkom University National Campus Network. With campuses located in major cities like Bandung and Jakarta, we provide a quality education that combines theory with practice, giving students access to a variety of industry opportunities and extensive professional connections. We are supported by expert lecturers and competent support staff, many of whom graduated from renowned universities both domestically and internationally. We also had state-of-the-art academic facilities, such as ProsMed Laboratory, Warehouse Laboratory, Computer Laboratory, with over 22 other laboratories ready to support student learning. We are proud of our achievements of our students who have won prizes in various national and international competitions, such as First place, Gajah Mada International Business Case Competition.
First place, National Nizit Confest 16 Competition.
First place, National Technology Work Competition 2024. Second place, National Creanomic Business Plan Competition. We are ready to face global competition. The Faculty of Industrial Engineering at Telkom University is committed to becoming a national excellent entrepreneurial faculty with international standards by 2028 in the field of information technology-based industrial systems focused on sustainable development. Together, contribute to the world at Telkom University.
Dalam pemenuhan kebutuhan masyarakat, tidak lepas dari kegiatan ekspor melalui penyediaan pelabuhan bertaraf internasional, pelindung tentunya diharapkan mampu mendukung para pelaku usaha di Indonesia yang ingin memperluas bisnis. Dengan pelayanan yang semakin cepat dan efisien, pelindung sebagai operator pelabuhan berstandar internasional siap bersinergi menjadi gerbang perekonomian Indonesia untuk dunia.
The Faculty of Industrial Engineering at Telkom University is one of the first faculties at Telkom University committed to producing a future generation ready to face the challenges of global industry. We offer excellent study programs with national accreditation as well as several internationally accredited, including Bachelor of Industrial Engineering, Bachelor of Information Systems, Bachelor of Logistics Engineering, Bachelor of Engineering Management, Master of Industrial Engineering, Master of Information Systems. Our faculty acts as a center of innovation in higher education connected in the Telkom University National Campus Network. With campuses located in major cities like Bandung and Jakarta, we provide a quality education that combines theory with practice, giving students access to a variety of industry opportunities and extensive professional connections. We are supported by expert lecturers and competent support staff, many of whom graduated from renowned universities both domestically and internationally. We also had state-of-the-art academic facilities, such as ProsMed Laboratory, Warehouse Laboratory, Computer Laboratory, with over 22 other laboratories ready to support student learning. We are proud of our achievements of our students who have won prizes in various national and international competitions, such as First place, Gajah Mada International Business Case Competition. First place, National Nizit Comfest 16 Competition. First place, National Technology Work Competition 2024. Second place, National Krenomic Business Plan Competition. We are ready to face global competition. The Faculty of Industrial Engineering at Telkom University is committed to becoming a national excellent entrepreneurial faculty with international standards by 2028 in the field of information technology-based industrial systems focused on sustainable development. Together, contribute to the world at Telkom University.
Dalam pemenuhan kebutuhan masyarakat, tidak lepas dari kegiatan ekspor melalui penyediaan pelabuhan bertaraf internasional, pelindung tentunya diharapkan mampu mendukung para pelaku usaha di Indonesia yang ingin memperluas bisnis. Dengan pelayanan yang semakin cepat dan efisien, pelindung sebagai operator pelabuhan berstandar internasional siap bersinergi menjadi gerbang perekonomian Indonesia untuk dunia.
Faculty of Industrial Engineering at Telkom University is one of the first faculties at Telkom University committed to producing a future generation ready to face the challenges of global industry. We offer excellent study programs with national accreditation as well as several internationally accredited, including Bachelor of Industrial Engineering, Bachelor of Information Systems, Bachelor of Logistics Engineering, Bachelor of Engineering Management, Master of Industrial Engineering, Master of Information Systems. Our faculty acts as a center of innovation in higher education connected in the Telkom University National Campus Network. With campuses located in major cities like Bandung and Jakarta, we provide a quality education that combines theory with practice, giving students access to a variety of industry opportunities and extensive professional connections. We are supported by expert lecturers and competent support staff, many of whom graduated from renowned universities both domestically and internationally. We also had state-of-the-art academic facilities, such as ProsMed Laboratory, Warehouse Laboratory, Computer Laboratory, with over 22 other laboratories ready to support student learning. We are proud of our achievements of our students who have won prizes in various national and international competitions, such as First place, Gajah Mada International Business Case Competition.
First place, National NIZIT Comfest 16 Competition.
First place, National Technology Work Competition 2024. Second place, National Krenomic Business Plan Competition. We are ready to face global competition. The Faculty of Industrial Engineering at Telkom University is committed to becoming a national excellent entrepreneurial faculty with international standards by 2028 in the field of information technology-based industrial systems focused on sustainable development. Together, contribute to the world at Telkom University.
Dalam pemenuhan kebutuhan masyarakat, tidak lepas dari kegiatan ekspor melalui penyediaan pelabuhan bertaraf internasional, Pelindo tentunya diharapkan mampu mendukung para pelaku usaha di Indonesia yang ingin memperluas bisnis. Dengan pelayanan yang semakin dan efisien, Pelindo sebagai operator pelabuhan berstandar internasional siap bersinergi menjadi gerbang perekonomian Indonesia untuk dunia.
We kindly request all participants to be seated again to grand building our plenary session.
Pada Bapak dan Ladies and gentlemen, welcome back to the Grand Ballroom. I trust lunch was enjoyable. We now move into the highlight of our afternoon program, the plenary session, expert panel Q&A, bringing together 3 experts at the cutting edge of our field.
To guide this session, may we now invite to the stage our panel moderator, Dr. Muhammad Arianto, PhD. Please come forward to the stage. Dr. Muhammad Arianto, he is a robotic researcher and lecturer at the Department of Mechanical Engineering, Diponegoro University, and is widely recognized for his pioneering work in cyborg insect robotics for search and rescue application, as well as AI-powered prosthetics, exoskeletons, and autonomous robotic systems.
Dr. Arianto, the floor is yours.
Okay, thank you very much for the conference. So in this session, we have three different keynote speeches, very excellent from Japan and Malaysia and Indonesia. So please introduce myself. My name is Muhammad Arianto. I'm from Mechanical Engineering Department, Diponegoro University, Semarang. So my research interest is okay. So my research interest is about wearable robotics, hybrid robot, and also autonomous system. Okay. So we have three different speaker. Sorry. Please come to the seat. First is Professor Keisuke Morishima. Please come to the stage. Preparation. And now next keynote speaker is Professor Dr. Abdul Wahab from International Islamic University Malaysia. Please come to the stage. And the next one is Prof. Dr. Maman Abdurrahman. So he is the head of CO Pratama Advanced ICT Infrastructure and Service Telkom University. Please join on the stage. Please have a seat. Okay. Okay, for the first session of this speaker, we will have Professor Morishima. So Professor Keisuke Morishima is a professor at Department of Mechanical Engineering and the Center of Advanced Medical Engineering and Informatics, the University of Japan. So he graduated from Nagoya University, where he received his PhD in engineering in 1998. In the next year, he was the GSPS postdoctoral research fellow from 1998 to 2001. He was postdoctoral research associate
at Department of Chemistry, Stanford University, United States of America. He joined Kanagawa Academy of Science and Technology as research of mechanical system engineering, Tokyo University of Agriculture and Technology, as an associate professor. In 2007, he joined Department of Biomechanics and Intelligent System. In 2011, he moved to the Department of Mechanical Engineering, Osaka University as a professor. He is mainly engaging in research fields of micro nanorobotic and its application to the micro manipulation, biomems, living machine, and soft and wet nanorobotic. So we are sorry that due to the delay. So each keynote will be given around 30 minutes. So after 30 minutes, we will be turn from one keynote to another keynote speak. And then after the keynote has been presented, so there will be question and answer section. For the first this keynote speak, please welcome to Professor Keisuke Morishima. The stage is yours. Please give Prof.
Okay. Just a moment. Oh, good afternoon, everyone. Thank you for nice introduction, Professor Arianto. So he got a PhD in my lab, so 2 years ago, and then we spent 4 years together, worked together with Arianto-san. So he had a very nice work with cyber insect. So today, so I'd like to appreciate this opportunity, especially Ronnie in the BRIN, and Professor Yuga and Arianto-san for all program committee, organizing committee of this conference. Okay, so you can see my slide movie, a lot of movie here. So this is ribbing material, ribbing components, like a cell, okay, muscle cell, and also muscle tissue, and insect, individual insect. So we have a lot of serendipity of the soft and wet material from nature. So soft and wet matter is a very, very promising material, futures, mechatronics components, I hope. So Professor Milford today, this morning, so I'm learning from nature, and so bio-inspired spirits. So I'm also learning from nature a lot, from nano to macro, okay. So here, this is a very simple experiment we have done. So my students, they're playing around the cell and the micro robot driven by a magnetic field. So this is almost 20 years ago experiment. So you can see the size of the cell is a 30 micron, 10 micron, and then micro robot rotating in a solution and then pushing the cell. It's a micro manipulator. So this is also, I like this movie, okay? So today's talk from nano to macro, from micro to macro. So first, I'd like to introduce how we can realize muscle actuators driven by chemical energy. Okay, here, this is a biological cell, time-lapse imaging. So you can see, okay, cell has mobility, so moving on the surface. Okay, this cell is a muscle cell from beetle larva. Okay, we like to build a muscle actuator from the beetle cells. Okay, so this is how you can see the biological cell. And okay, so how we can integrate the living material and synthetic materials, okay, artificial, so combine how we can implement this idea, architectures. So actuation is a challenge, okay? So all components from conventional robot, so driven by electrical motors so far, so driven by electrical energy. So our nature is driven by chemical energy, muscle-based actuators. So actuation is one of the challenges. So chemical energy driven, okay? And how we can assemble from nano to macro, that is also a big question. So we can learn from nature the mechanisms, the self-organizations. So we need to understand how we can realize the self-organization manufacturing, okay? And intelligence, okay? This conference, Smart Mechatronics, we like to learn how we can mimic the intelligence from nature, okay? And so compete then, so artificial intelligence. So this movie is last year in Japan, Osaka, we have a World Expo 2025. So Professor Sawa is famous cardiosurgery professor in our university. He has developed so heart muscles, from heart muscle cell to heart tissue. His challenge is to build a real heart tissue from heart muscle cell, okay? So you can see the heart muscle cell is beating in a solution. So he demonstrated, so 6 months in World Expo in Osaka. So you can see, so here's the size is, okay, about the coin size. So in our heart, it's like, it's more than big ball. So this is still challenging to build a 3D heart tissue. So you can see the beating heart muscle cell. Okay. So 20 years ago, okay, 26 years ago, okay, when I was a postdoc, so I was very impressive to see the heart muscle cell contraction, the biological cell level. So then, so I learned the chemistry, biology. So I'm from the MEMS people. Okay, so where to go next is a bio-inspired innovation. Okay, so many people. Okay, so biomimetic, bio-inspired, bio now, so bio-hybrid. Okay, that is very big challenge. So we can learn from these architectures. So not 3D, 4D, but natural and corrective nature. And okay, of course, manufacturing. So bottom-up approach is often utilized in nature. So top-down approach, okay. Our approach is almost top-down approach. So one of the idea is how we can scale up for large-scale integration, learning from natures, from bottom-up approach and top-down approach. That is one. Okay, so this slide shows various kinds of our studies to develop the bioactuator based on the master constructions. First, we confirmed the heart muscle contraction, beating, continuous, enormous beating. Using this mechanism, we developed the heart muscle pump. And also we show some insect muscle in the insect muscle tissue to build a micro gripper, micro mobile robot so far. And then recently, so we focus on individual insect and intelligence and mobile robot. Okay, as I told you before, this is a demonstration, the micro pump, so actuated by heart muscle cell. As you can see, so this is a cross-section view of the diaphragm pump, the conventional micro pump. So we immobilized hard muscle cell sheet on the top, and then we visualize that inside the microchannel. You can see the micro beads are moving forward. So we successfully demonstrate fluid actuation inside microchannel using cardiomyocyte seed. Okay, so this is the concept. So materials from the real biological tissue, like a heart, and then we culture the cell, and then so reconstruct the cell sheet two-dimensionally at that time. And then we built the top-down approach using MEMS technology to build a diaphragm pump, and then attach this actuator on the top. And then we demonstrated fluid actuation. This is a biohybrid devices. And then, so last year, I told you 3D heart tissues so realized. But still, we have a lot of challenge to build a real size of the heart tissue. Okay, this is also one of the challenges, how we can mimic the muscle and neuron communication to control. So neural signal control the muscle. So this is a very simple experiment. So we construct the micro gripper structures by soft materials, the silicone elastomer, and then we immobilize the muscle fiber made by skeletal muscle cells. Okay, we published the Tissue Engineers journal, and then, okay, the experiment. So you can see this movie, we monitors EMG. Then the students move the arm, so we can see the EMG signal. Using this signal, we like to control, we apply electric field to the skeletal muscle fiber, and then we observe, and then we try to predict the model relationship between neural signal and muscle action. Okay. This movie, you can see the ring structures moving towards the bottom. Okay, so this is why they move, contract. So I mix with the heart muscle cell and hydrogel, the soft material. So first, we like to mimic a jellyfish floating in water. So because heart beating, autonomously heart beating, contractions continuously. So, and then I'm very curious about what is the mechanism, how they communicate inside hydrogel and muscle cell. So we can visualize when the muscle cell contract, so you can see the fluorescence. So this means chemistry, the chemical wave. So this is how they can communicate. Then, so we are thinking about how we can design, how we can mimic these architectures. So very simple solution. Oh, sorry. Okay, sorry. Then next, okay, here. So this is a net, you can see the several different network design. So we learn electrical circuit. So wide wire and longer wire, shorter wire. So resistance change. So this means signal change. Okay, so you can see the 3x3 networks. Okay, so image processing, we can measure very easily velocity, acceleration, and position immediately. So this is, okay, first, just curiosity, how we can move, okay? But we have a lot of data from these devices because they respond by chemical. It's like a medicine. So medical doctor study some medicines, how we can stop the heart, how can accelerate the heart. That is then. So pharmaceutical company are interested in these devices to evaluate new drug discovery. Okay, so the people conventionally use a biochemical reaction, analytical chemistry. This is combined with the AI data set. Okay, so next, as you can see here, so this is a lot of people dream to realize soft motion, right? And flexible and wireless and also autonomous and self-sensing. So this is a real insect, okay? So many people mimic this actuations using hydraulic actuators, air pressure pump. So our approach, how we can mimic the muscle. Okay. So here, using their muscle, we demonstrated micro mobile robot, this environment inside a solution. So the fundamental principle of the how we supply energy, the chemical. So surrounding chemical is a fuel. So as you know, the muscle is driven by ATP, sugar. Okay. So this is a cross-section view. Okay. So then how we can realize the outside the body. We have covered by skin, the muscle, other tissue. Just simple try. So we have used material the same as a contact lens. So because oxygen is absorbed, it's transparent and to see inside. Okay, so the actuator is used by insect muscle. Okay, so you can see the gripper, so contract. Yes. Okay, so I explained several challenge. So bottom-up approach, top-down approach. I show the devices and muscle contractions. So how we can integrate and big challenge and self-organization. So we utilize a biological cell. It's already self-organized from molecules, protein molecules. Okay, so I will explain how we can realize devices using self-organization in nature. Okay, next. Here, so this is not the muscle cell contraction. So we utilize motor protein inside the cell. So we utilize 3 different components of the motor protein. So you can see, so this is kind of gripper. So surrounding by solution, okay? Inside the solution, we have 3 different proteins. And then we expose the light, UV light, and then contractions happen. Okay, this is we call printable muscle. Okay, so we publish it Nature, Materials, Science, Robotics. So this is okay. We collaborate with biochemists, biophysicists to design new architecture of the printable muscle. Okay, so as I told you, 3 different materials. There's but simple assembly, but simple rule. Okay, here. So how we can mimic linear motion here. So we need a rail, right? We need also scaffold. Also, we need a fiber. So how we can, we need to prepare fiber, scaffold, rail. So biochemists, biophysicists, we discuss about. So very simple motor protein we use. So in nature, and also genetically modify. We can control the switching by light. Okay, so then we can switching on and off the contraction. So this is a bottom-up engineered design architectures. So conventionally, mechatronics, okay, input and signal, output signal, okay? So black box, okay? Here is it's kind of the actuator, but assembling mechanism principle, self-organization. This is learned from the working together with biochemistry. So we call dynamic self-assembly, and from nano to microscopic scale, large scale integration we can. And so another important thing, network, from nano to macroscopic large scale integration, it's how we can design network. And so finally, we successfully demonstrate printable muscle, okay? So I will show you how application of this actuator inside the microchannel. So you can imagine assembly line micro robot. First, we construct a structures, skeleton, and then moving inside the channel, and then we expose the light, and then assemble the actuator. Here is one of the example. You can see the scale, 200 micron. So you can see the gripper. So here we expose the light, then and conditions start, and then gripper is closed. And this is also inside the microchannel. First, we fabricate 3D printing these structures, and then we flow. This is a microchannel, the protein solution flowing in this area, and then expose the light, and they assemble. Okay, this is also two channel, a different channel, and then we can replace as actuator. This is a different concept. So here, finally, we have developed the manufacturers two different gripper manipulator, and then we successfully demonstrate the manipulations, and then we published Science Robotics this work. Okay, finally, so I will introduce our work based on cyborg instinct, natural behavior, biohybrid autonomy, intelligence. So this is a concept we work together with Sato Sensei in Singapore and Wakami Sensei in Osaka University, Moonshot Project. So you can see in this figure a lot of robot and human rescue, and you can see rescue dog, also ocean. Okay, a lot of drone and a lot of network. So 5G, 6G, we need very quick communication, telecommunication, and then you can see a lot of satellite and moon, Mars, on the space. Okay, everywhere. So network. So then, so a lot of opportunity, possibility connecting the world and the AI. So 2050, many things connecting, and then how we can utilize this opportunity. So cyborg insect, one of the tool to rescue the people, disaster areas. So conventional robot cannot go inside. And so as you know very well, so we have used Madagascar cockroach, 7 centimeter, 8 centimeter size. So it's a very simple one. So Arianto-san, Professor Arianto, coming to Japan, Osaka, and then we have started. So how we can realize, integrate this, and also how we can utilize this one. And a fundamental question. Okay. So fundamental question. bio-hybrid autonomy, how can we define bio-hybrid intelligence? Okay. In nature, insect is very intelligent. Okay, but it's very simple. Okay, and also we immobilize computer chip. Okay, bio-hybrid intelligence, disable, and establish design principle for bio-hybrid autonomy. So Professor Arianto working very hard to think about, okay, we observe many hours their behavior. Yes, and to look around the design principle. Okay, they like free. They like freedom. Okay, not control. Without control. Okay, let's use it. Autonomous. Okay. So, sorry, it's a very busy slide. So our concept is one of the concepts is up here. The bottom one is conventional insect cyborg. So you can see the object is an insect and the environment, surrounding environment interact with each other. And the right box is AI. So we have a lot of sensor, the cyber insect, to monitor the physical data and also kinematic data. We have tons of data and then evaluate, analyze AI, and also insect interaction with the environment, and then how they feel, how they behave, how they think. Okay, like a upward. So that is very simple. So the reality is we don't know how they feel, how they think, how they try. But AI, okay, using AI, okay, we can define some rule. We can discover very simple rule. So that is the idea. So how? Or we observe a long time to know natural behavior. And then, okay, this is a sequence of our cyber insect. So you can see our strategy is this green box, biointelligence. This means, so we have a lot of sensor. It's like a receptor, protein, sensory neuron, and then go to the brain and motor neuron, actuator, the muscle. This is a principle of decision making, how they behave, how they move. So conventional cyber insect has utilized electrical stimulation to the antenna and cell sea. So this is looks natural stimulation, but it's not natural stimulation. So control things. So then we have embedded distance sensor, artificial sensor, for example. And also we like to monitor neural signal because nerve recording is very, very important. How they feel, how they think. Okay. So combined with, this is the sequence of the sensory control and motor control. So here you can see the sequence is here. So as I told you, receptor to the actuator. So, and our strategy is, okay, we have used IMU and distance sensor. So we stimulate depending on the IMU response and then go to the receptor. So because we didn't utilize electrical stimulation, we apply the UV stimulation because in nature, so insect responds to the light and very naturally. That is a big difference at the sequence. So then we realize more natural behavior control. So that is natural perception based behavior. And Arianto-san called biohybrid behavior control. Okay, so again, so our stimulation method is a more natural way, not electrical stimulation, but UV optical stimulation. So here is a result. You can see. So this insect has 2 LED near the head. So we call UV helmet. So this LED stimulate their eye, so they respond to the light and left, and we can control the move in more naturally. Okay, so we utilize visual perception, natural perception based control. So and we have a lot of sensor here. So this means biohybrid behavior based control. So here, so this is a experimental demonstration in the tail end area. You can see a lot of obstacle and not flat surface. So Arianto-san and Mas-san, my students, he demonstrated so using phototactic response. Okay. So as you know, this cockroach likes a corner and a wall, near the wall and a dark area. This is a natural behavior. So how we can utilize more positively. That's the simple way, not push, push, push control. The freedom is very important for natural perception control. Okay, so this is a typical result. We monitor trajectory. It looks not efficient, but finally they reach the goal. That is more important to rescue. So we find the people under the rock. That's one is most important things. So they try to find. So again, this is our cyborg insect architectures. So we like to utilize natural perception and biohybrid behavior. Okay, so this is Professor Arianto's work. So wall following behavior is natural behavior. They like the corner, but they try, okay, you can see stack, but they can escape successfully. They can climb on the wall. It's a very free, natural way, natural behavior. So positive controls. So we like to utilize more natural behavior, natural perception. That is our architectures. Okay, so this is also a lot of trials, trajectory, but finally they find the goal. Okay, this is a natural behaviors control. Okay, so next, finally, I'm more minutes. Okay, so this work is done by Professor Sato and Wakamiya Sensei and Moonshot Project. So next, I will show the videos swarm with the cockroach. Okay, so you can see here 20 cockroach, cyber cockroach. In the middle, you can see this is a reader. So, okay, they don't know the position, each other, but leader try to know the neighbor. Okay, we use the camera first. And then you can see stimulation off. Now, you can see the movie here. So other cyber insects going to the leader, and then leader, okay, followers go to the leader, and the leader goes to the goal. Okay, so we mimic the ant, so follower. Okay, so actually, as you know, the cockroach is not like an ant, bee. It's very, very difficult to control. So, but we can learn. If we set a simple rule, we can control like a swarm, a lot of tasks. So this is fundamentally it's interesting. Also, a lot of application, I think. So you can see, so this is a very exciting work. Sato Sensei's hard work. So you can hear it's not a movie. Yes, but it's very tough. So today's Professor Milford talks rat slum. Rat is more intelligence. The cockroach, simple rule. We set a simple rule, and then it's like a rat. And Tang is also working on this one. Okay, so here is a big dream in a moonshot. So robot everywhere in a home, in not only industry, autonomous car and drone, home. So people collaborate with a robot, and then okay, you know, in Japan, reduce the population a lot. We have a lot of elder people. We have to think about. So how we can, okay, so work together with the robot. That is so we like to learn from the cockroach. This is a moonshot project. So swarm self-organizing superorganism. That is a biohybrid autonomy in the future. Okay, thank you very much. My talks. So thank you for your attention.
Yeah, thank you. Thank you very much for your presentation, Professor Keisuke Morisma. Please return back to him. Please give him applause again. Very interesting research about how to combination between living thing and also robotics. So this very unique research. So I think in our country we can also advance this kind of research. Yes, thank you, Professor.
Thank you very much.
Now the second keynote speak is Professor Abdul Wahab. So I will Professor Abdul Wahab began his career with Hewlett Packard, working in Singapore and Colorado, USA, before joining an NTU Singapore in 1990. In 2009, he joined the Kuliah of Information and Communication Technology, International Islamic University Malaysia, and he served as visiting researcher at NTU and San Diego State University, and as consultant to Omni Design Singapore for ergonomic info devices. He chaired the technical committee reviewing safety standard for IT requirement and held leadership roles with Singapore Islamic Religious Council, Malay Chamber of Commerce, and various community organizations, including Mercy Relief. His current research focuses on neurocardiological modeling, EEG, ECG, to understand brain and heart function with application in learning disorder, addiction behavior, emotional stress analysis, driver profiling, PTSD, epilepsy prediction, and neurofeedback. He also developed computational model and physiological instrument for brain-inspired, effective, and blended care. So his title will be AI Brain Analytics for Mental Well-being and Interfacing. So Professor Abdullah, the time is yours. Thank you.
Thank you very much. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. What I'd like to do this afternoon is talk about AI brain analytics. I think a lot of people are talking about AI, but I'm going to focus on brain itself and especially EEG, okay, or electroencephalography. Okay. Now, what it is basically, I'm going to skip all that. if you look at the brain itself, which every one of you have, I suppose, or better be, right? Or else you will be in trouble. We have, for many years, a lot of research has been carried out, and we have actually break the brain into a few regions or few areas. One of them, which is very important, and I've seen quite a number of research that quite a few of you who are using the backside of the brain, which we call the occipital region. Okay, you notice that when you close your eyes, this is where your alpha wave will start to travel from the occipital region all the way down to the frontal area. Okay, and it is very important that you have that alpha wave. And without this alpha wave, that means your brain is already dead and you are in trouble. Okay, because as far as we are concerned, our brain relies on the alpha wave. So that is the occipital region. Okay, and right in the front here, which we call the frontal area, and that is very important because a lot of us needs that, okay, in order for us to actually make use of the brain for our intelligence. Okay. And then these two areas, which we call the parietal area, or the temporal lobe, is where if you have a problem with language, okay, for example, like you want to understand, you listen to different kind of voices, people with dyslexic, you will find that the left part and the right side is not balanced. Okay, and the other one is the parietal area. That's where the most of the sensory cortex is going to be. Okay, but we're not going to go into that detail. What I'm going to give you some idea is the flavor, so that when you found, oh, it is quite interesting, So I want to do more research on this brain, and you don't have to worry about it, okay? Because it's quite interesting, and a lot of research can be done with respect to the brain. After all, every one of you have those brain up there, right? Okay, let's see. Oops. Yeah. If you look at the brain, the way medical doctors and a lot of people have been doing it, as far as measuring the brain, we have, of course, the EEG, fMRI, the PET, SPEC, and NIRS. Of course, fMRI, doctors use those to actually to see whether you have any brain tumor, cancer, whatever it is, okay? But we cannot use them as robotic engineers or as computer science. We don't make use of fMRI that much, except when you want to really help the medical doctors in finding where the tumor is so that we can fire those brain tumors and get rid of them. PET is another types of devices where you can measure what is happening to the brain. In other words, there are a lot of devices that you can use to measure the performance of the brain. But most of them, if you find, they are giving you the physical location where your brain has got problem and so forth. But the best, as far as temporal information is concerned, is to use the EEG. Okay, because it gives you the temporal, but it cannot pinpoint to you where or which part of the brain has got problem. It cannot. Okay. And this is your EEG signals. It's really not that bad. If you look at signals and you analyze signals, you'll find that, hey, yeah, there are a lot of alpha waves, beta waves, and whatever waves that we can analyze. Okay. But what is interesting is that a lot of those who do research on brain, you will find that you must understand some of these basic frequencies fundamentals. Okay, I've asked a lot of students down there. Most of them just knows, yeah, I work on these frequencies, I work on that frequencies, but what are they for? Okay, so I think that is the wrong way to look at brains. My recommendation is understand each of these band of frequencies that you want to work with the brain. Example I give you, the delta waves is the slowest wave. As far as the brain is concerned, it works from 0.5 to about 4 hertz. When you are deep asleep, that particular part of the brain becomes active. In other words, the frequencies of up to 4 hertz, very, very low frequencies, it will be very, very high. So if you use the EEG to measure, you will find that that is the highest, frequency. Now, but what happens if you start to open your eyes and suddenly you find that you have that delta wave? There is a high likelihood I would recommend you to go and see a neurosurgeon to cut your brain open and see what's wrong with your brain. Okay, so that's what happened. And theta wave is an interesting wave. Okay, it is from 4 to 8 hertz. But when you are drowsy, about to go to sleep, you have not gone into sleep, that particular wave will actually be activated. Okay, and these are called low arousal wave. Alpha wave is your dominant wave. Okay, every one of us, when we are relaxed, having good time, that is where your alpha waves. You're very calm. Okay, you are awake. Wakefulness. If you talk about wakefulness, yes, that's where you actually have the alpha wave. Okay, and those are the low to moderate. And of course, the low beta. Low beta is when you start to think. Okay, you are not doing a lot of mathematics thinking. You maybe do some simple arithmetic and you find that beta waves will be the one that is going to be high. Now, in this particular case, you also have the highest part of the beta, which is from 21 to 30 hertz. Okay, 21 to 30 hertz. And this is where you have the high arousal. Example, when you're getting anxiety. I'm getting excited because I want to present this thing to you. So my higher beta will goes up. And that's what happened. I've not talked about where it happens. I'm just talking about the frequency. So therefore, please bear that in mind. If you want to do research on brain, do not leave this thing out because they are very important. I give you an example. If you have a very high arousal, and then suddenly you measure, hey, I want to measure, that 12 hertz or 13 hertz, and then I want to use it to control my robots. Oh boy, you are in trouble. Because when you are excited, what will happen? That particular frequency will go high. Okay? And therefore, you will find that controlling robots when you are having excitement or when you are having angry, controlling the robot will be really interesting. And you'll find the robot arm will take your neck and really, get you into trouble. So please bear in mind, okay? You are dealing with human. The brain is a human brain, okay? So therefore, please bear in mind that you really need to analyze them carefully. Like here, I'm getting excited because when I press a lot of buttons, it will not work. Okay, how are they related? First, low arousal. Example, I mentioned sleeping, meditating, or you are being bored. Some of you are being bored because I'm talking to you now. So you can see that, your theta wave is getting higher. Okay. Moderate arousal, like you're calm, you're just having fun with reading, you do a little bit of work. And hyperarousal, anxiety, ADHD. Okay, ADHD is a hyperactivity. Okay, so when you have hyperactivity, what will happen is that in ADHD, your theta beta ratio will be very high. Okay, this is part of the NIBA standard. If you look at the NIBA standard, you will find that the theta beta ratio is very high. There's a likelihood that your child is having a ADHD. So therefore, in this particular case, yes. How can we control them? Then you have to try and look at the theta wave, bring it down and so forth. I will show later how we can actually do them. Okay. Okay, let's keep that. In EEG, there are actually 3 different analyses that you can do in EEG. One of them is what we call the frequency analysis. In other words, I'll look at the band, okay, and I know this is alpha band, beta band, whatever band it is. Or I can look at time domain analysis, which is called the morphology analysis. I look at the wave. Sometimes the wave have a very sharp edge. Sometimes the wave has a very curved edge, or sometimes it has a double curve, and those are morphological analysis, and it can also be done in that particular context. Location, you want to know where. Like for example, if this guy, we were doing some work with Ibu Eli in Jakarta about trying to identify students with porn addiction. I just look at the front wave here, the frontal area. Okay, and most of them who has problem will have a frontal area with very inactive alpha wave. So when the alpha wave in the front area is very inactive, then there is a high chance that your resilience to addiction is very, very low. So therefore, there is always a recommendation of what to do and so forth in that particular context. Okay. Okay. So how do you measure them? In general, there are rules. Okay, there are rules on how you measure them. This is called the 10-20 system. In the 10-20 system, you take your whole area here, you break it into 1, 2, 3, 4, 5, and then you take 10%, 10%, 20%, 20%, 20%, that gives you a total of 100%. Okay, so this is a 10-20 rule. On total, you're going to have a 19 channel there. Okay, so therefore, this will give you a very good idea as far as where you're going to put your EEG probe. Okay, so you just don't put it anywhere you want. Okay, this is to give you a very, very good idea as far as the location of your probe. Okay. In the clinical area, one of the things that we have, as I mentioned earlier, we have ADHD, okay, or attention deficit. In this case here, you often show the high frontal theta-beta ratio. Okay, that's something you can do. Cognitive fatigue or burnout. If you are burnout, then you can really measure the frontal alpha, beta, or alpha theta ratio in this particular case. And peak performance training. If you're an athlete, you want to see how you can really go for the peak performance, then you can really try and look at some of these waves that we will go through. In neurofeedback, example of a neurofeedback will be, for example, someone who have migraine. Migraine is something that occur when your wave is very, very low. Even lower your delta wave, lower than 0.5 hertz. You have a very, very slow moving wave. And we can really do neurofeedback to train you to improve your migraine situation. And we have a lot of cases in our lab where they come to us and we really do neurofeedback and let the brain train so that you can improve your migraine situation. And it really helps a lot. Okay. Okay. Yeah, this is our lab. Can I have the voice? No voice. This is in IIUM in Gombak area, the Kuliah of ICT. So if you visit our lab, let us know. We can show you what we have in the lab itself here. And inside the lab, yes, we have the neuro room. Okay, we do all the EEG measurement. Okay, because caffeine really puts your EEG signals on haywire. Okay. Okay. Okay, I want to switch gear. Now that I've shown you what is the neurofeedback as far as IIUM is concerned, you can visit IIUM Neuro Coach Digital Lab. Okay, and if you want to actually do your brain scan, we can do your brain scan. Don't worry, it's not painful. Okay, it's non-invasive. But I want to switch gear and talk about emotion. There are a lot of people here who kind of see emotion, just the valence part of it. Okay, not the arousal. You see, what is important about emotion is that if you look at Russell, Russell defined emotion. Okay, Russell defined emotion as a part where you have the activation and also the valence. The valence is where you have the unpleasant and pleasant. And the arousal is the activation or deactivation. example I give you, if you are happy, for example, you are in this particular quadrant and you will have positive valence and positive arousal. Okay. And if you are angry or you are upset, you are in this particular region where you have a negative valence and positive arousal. And if you are sad or you're bored, you will be in this particular region where you have a negative valence and negative arousal. Okay. And when you are calm down, you are really relaxing, then you find that you have a positive valence but negative arousal or negative activation. Now, this particular affective space model here tells you a lot of information by which we need to establish standards. What are the standards of emotion? Example, the way how your brain reacts toward a happy emotion and how my brain reacts toward a happy emotion is very different. So how do we establish the standards? That is why we have to use what we call the International Affective Picture Standards, or IAPS, IAPS. These IAPS will have a picture standards by which, if you look at the picture, this is a happy picture, and my definition of happy will be the same as your definition of happy, but the way your brain wave works will be different. So now we can actually synchronize the two and say, hey, this is happy. That means I have a positive valence and positive arousal. Okay, and that becomes very important and critical. And especially for some of you who are doing BCI, okay, BCI, therefore we need to standardize the arousal so that when this guy is really happy, I know that he is happy and this is the degree and I have to compensate those happiness, okay, to control my robot situation, okay. In movement, we also have the V and A in terms of the motion, okay. Let me tell you why I have that V and A in terms of the emotion. Like here, can you see there is one of these two kids, okay, who is actually autistic. Can you see which one? The boy or the girl that is autistic? The boy, right? Yeah, the boy is autistic, and this boy here, you will find that autistic children, they very seldom want to see you on the face. Okay, they have this taboo that they want to see you face to face. Okay, they always will hide. Yeah, that is the autistic children. But for mild autism or Asperger syndrome, we call it, you will find that it is very, very difficult to identify them. So how do you do that? So we actually want to do an early detection so that with that early detection, we can do early intervention. And when we can do early intervention, we can help these children to lead a more normal life. And that's very important, okay, because we want to help them. And most of us here in Indonesia, in Singapore, in Malaysia, even in Thailand, the ASEAN countries, we have this taboo that if your children is autistic, you are gone. It should not be. If you have early detection that you detect your children is autistic, you can do a lot of intervention to help these children to lead a more normal life. Okay? So therefore, my recommendation is that when you suspect, get it, really go through the brain scan, go to the psychiatrist, psychologist, and find out what is happening. Okay? In here, in Jakarta, we have the National Institute of Mental Health. I was working with Dr. Suzy. She is the Kapala of the NIMH. And yes, she is handling some of these children with those autistic children and some of the other brain developmental disabilities. Okay. So how do we identify them using the EEG? So because right now it is very expensive to actually go to a psychologist or psychiatrist to do some of those measurements and so forth. You have rare or very little number of psychologists and psychiatrists. So with this early detection, what we did was, this is an example where we were working together with the hospital in Penawa Hospital in Johor Bahru in Pasir Gudang. Okay, and you will find that one of the measurements we did, these are the children. So we actually equip them, you can see, and they are playing same games. We monitor their head movement, and then we measure the EEG pattern. Okay, of course, we have to get rid of all the noise and so forth. especially when you actually deal with children, autistic children. So the most important is that you need to have eyes open and eyes closed measurement for 1 minute to understand what is going on as the initial part. And then we introduce this emotion. Okay, you remember I talked about those emotions, happy, fear, calm, and sad emotion. Yes, we actually monitor them. And from that emotion, we extract what we call the arousal. Remember, we have the valence and arousal. I just extract the arousal. And from the arousal, I do this measurement. This is part of the normal children, and this is part of the autistic children. Just the arousal. What differences can you see from these two? Yes, you can see that as far as the normal children is concerned, you see the arousal really varies, okay, from positive to negative. Can you see the variation there? But for these autistic children, they're always negative. You see? Because of the way they behave, their brain behaves toward it. So therefore, once we can detect this, then we can actually put them into the psychiatric or the psychological therapy, okay, to help them in doing the training and so forth. But we have this special case here. Can you see that? Initially it's very high and then it goes very low. This one here, because this guy, this particular children is mild autism. In other words, we can identify using the EEG to see whether you have your children, which is normal, or in this particular case with the autistic, including the mild autism. Okay, so that would be really an interesting things to study. Okay, so therefore it is interesting that we can actually discriminate and the accuracy is around 87% in this particular case. Okay, but anyway, we can do the validation through the psychological instrument or the psychologist for that particular method. Okay, I want to switch gear. Rather than just using that particular technique, I also can use this particular technique. In this case here, we extract the delta wave, theta wave, alpha wave, beta wave, and the gamma wave. But we never use gamma wave. Gamma wave are just too high, okay, for any of our analytics. We only use the delta, theta, alpha, and beta wave. And then we do some feature extraction, and then we look at typical U-shaped curve or an N-shaped curve with the children with autistic or non-autistic. These are established work that has been done. Okay, there are a lot of publications on this. An example I give you is that for the autistic children, you will get a U curve like that because you actually plot the delta, theta, alpha, and the beta gamma wave. If you do something like that, you will get a U shape. That will be autistic children, and for the N shape will be the normal children. Okay. Here I've shown you some examples of how you actually do it. Okay, using these different types of what do you call that? For the ASD and the normal and the autistic children. But if I combine everything together, you can see from here, okay, that this is subject A, B, this is C, and this is D. Okay, so you can see the N here. These are normal. The hue here is actually the autistic children, and normal. Okay, U is autistic, and so forth. Okay, and this one here is using what we call our method based on arousal, whereas this particular one is using the time domain analytics. A lot of the cases, people are using this time domain analytics, whereas we are now introducing the new method, which we call the arousal analytics. Okay, so therefore, in this particular case, you can see it is much clearer in using our analytics compared to the time domain analytics. So most of our analytics now, we are using it based on the arousal analytics. Okay. In addition to that, we also can identify children with comorbid cases. Example, sometimes you have autistic, but including autistic, you also have ADHD. Okay, so how do you identify them? So we have used this particular technique, and you can see from here, okay, like here I have subject A, B, C, D, E, F, G, H, okay? And here you have children with autism, right? Okay, mild autism. And we also have the one with dyslexic, like this one here, see? These are autism, and you have ADHD with dyslexic, ADHD, dyslexic with ADHD, and these are the normal children. So you can actually identify them quite easily in this particular case. For those of you who are very interested to know about this research and more, please, you can always contact me. Okay, this is both using the positive emotion and also the negative emotion. Okay, let me switch gear. In general, this is what the 19th channel is all about. We have the frontal, okay, we have prefrontal, we call it. These are the frontal area, and then this is the central frontal. These are the temporal area, and these are the central area. These are the parietal area, and these are the occipital region. Okay, I saw that a lot of the project today, you are using the occipital region because you are trying to observe what the eye is actually looking at. Okay, that means you look at the eye, you want to control the movement of your drone. Okay, that whatever you do. Unfortunately, if you just do that, sometimes it works, sometimes it doesn't work. The reason is because human brain do have emotion. Okay, unless you remove the emotion part of the human brain, then you find that, yes, it will consistently work without any problem. But then after that, you have problem because this particular emotion, this particular human brain do not have emotion anymore. Okay. Okay. So this is the one of the work that we have done earlier. You notice we don't use the cap. Okay, but we use the measurement. But now with the cap, it's much easier. Okay. So, but you can still use the measurement. We use the tape to measure, and then we take the 10%, 20%, 20%, and 20%, and the 10%. It can be done, and for those, some of my students who have done it very, very well, they can do the whole setup in less than 5 minutes. Very fast. So, really very nice. Okay. Okay, what I want to show you is that I can also measure the, based on the five-factor behavior. Okay, that means the psychological instruments that used to measure the five-factor behavior. Okay, so I can look at the openness, conscientiousness, extroversion, the agreeableness, and the neuroticism. Okay, and by that, what I did is I do a correlation study between the emotion, happy, fear, calm, and sad, and the five-factor behavior in this particular case. And from there, we extract the happy, fear, calm, and sad valence and arousal of the EEG. And then at the same time, we did the correlation study. And here I will show you some of the correlation studies. In the end, although the number of subjects is not enough, but if I want to measure the neuroticism, I can just make use of the T-score or the trait score, and I can get around 90%, okay, types of accuracy. Okay, and if I want to measure the extroversion, okay, I use the T-score or the trait score. Like the trait score here, I can have an accuracy of about 95%. Okay, which is quite good. Okay, I can extract using the brain signals. The only thing I cannot do, because these are all from the university student. What happened? As far as agreeableness, none of them are agreeable, okay, because they are university students. Okay, which actually coincide very nicely. Most of the university students will argue with you, a lot of argument. So therefore, agreeableness, we cannot get a very good correlation study on this. But if you go into a public relations study, then you find that, yeah, there are a lot of information that we can get here. And these are very, very interesting because we can actually present this to the executive officers, and they can make use of this in order to tell you what kind of training will be best for you. Example, in the military, you know, if I want to use this, right now, we are working closely with UPNM, University Pertahanan Malaysia. Okay, so that we can use this to actually understand their behavior and the kind of training and the kind of military, you know, that is best suited for this individual. Okay, so therefore, we can do something like that. But whatever it is, please be careful. Don't get the politician into this particular area. Maybe you'll be in trouble. Okay, but anyway, yes, you can measure them. We are using what we call the neuro-computational model of effect, that we can use them to measure, for example, dust, the depression, anxiety, stress tests, in this particular case. And a lot of study that we have done are based on the psychological instrument. And then we do a lot of correlation studies based on the psychological instrument. Okay. Okay. This one is interesting. I mentioned earlier that we work together with Ibu Eli in Jakarta. She is doing a lot of parenting. You must have heard them a few years ago. Okay, so this is the study we did with them. What we do was we want to measure as far as a brainwave, and then we correlate it with the psychological studies. Okay, and we have altogether about 14 participants. Okay, nine boys and 5 girls. Okay, and we measure their brainwaves. I just want to show you here what I'm doing here for this addicted subject. According to the psychological instruments, the psychologists actually interview the parents, the teachers, and these students have got problem. Okay, they are addicted to pornography. So we just look, if you just focus on the frontal area for the delta wave, theta wave, alpha wave, okay, beta 1, beta 2, okay, and the gamma wave, just the frontal area, okay? And also looking at the non-addicted, we have addicted and non-addicted, and just looking at the frontal area, okay? Let me show you a simple plot that we have done. This is called a fuzzy plot, right? So if I do the fuzzy plot for the theta wave, the beta wave, and the alpha wave, in this particular case, this particular axis here tells me the amplitude of the power, okay? And this particular one tells me whether they are addicted or non-addicted. Okay, so I can see that, hey, the red color here shows addicted by the psychologists. Okay, and the blue one indicate that, hey, they are normal, okay, or non-addicted in this particular case. You can see this region here tells me that the theta wave has got a wide spread as far as addicted to non-addicted. Whereas the best is the alpha wave. So if I want to measure the alpha wave frontal area, and then after that, I can really differentiate or discriminate between the addictive or the non-addictive in this particular case. So this study here indicate porn addiction, but you can do with a lot of addiction. One of the addiction you can do is obesity. Is food addiction. Okay, so you can look at obesity, at food addiction, that people who likes to eat food, they cannot see the picture of food, they become excited. Okay, so in this particular case, you can look at them and yes, you can see these particular issues. In fact, in a lot of work that we have done recently, we do have quite a number of people who come to us. Okay, and then the first thing we did was to look at the frontal area. And one of the indication of the frontal area is that if you have not done any kind of meditation, okay, in other words, you never meditate at all, you never really make use of your frontal, because the frontal area is your executive function. These are the people who will have problem with addiction.
I'm sorry, Prof. So we have time limitation.
About to finish. Okay, let me just quickly. We also have this one here. I want to show you. Eustress and distress. Eustress and distress. What is that? In other words, if, for example, you have no stress at all, it becomes boredom. Okay. If you have too much stress, then you have burnout. Okay. The ideal will be if you have a little bit of stress, but not too much stress. So therefore, one of my PhD students actually measure how can we find this optimum stress. Very quickly, he measured all the
psychological instruments based on academic stress, AD stress tool, both stress tool, and so forth. Okay. In the end, we can derive a model, okay, by which we can identify, okay, the eustress and distress of a group of people. Okay, so from there, we can then find an optimum point, okay, where this particular individual or group of individual can take up the stress, okay, and yes, when is it and what is the best point in this particular context. Okay. I'm done, is it? Lastly, I just want to mention, we use another method as far as EEG, we call it the ERP. ERP is the evoke or early event-related potential. In the event-related potential, we try to identify mental fatigue. Mental fatigue. So this is what we do. We look at this is called the ERP, the P100, P200, 300, 400, and so forth. And we can from there identify, okay, that, hey, if I want to measure, for example, fear and happy, okay, it's best that I look at the frontal, there's two frontal here. But if I want to measure sad and calm, it's best that I look at the central area. And if I want to actually measure, this one here, as far as arousal is concerned, so this is what I can do as far as the ERP is concerned. Okay, I think I better stop there, is it? Yes. Thank you very much. And thank you, ICSMech, for it. Thank you. Assalamualaikum.
Please give applause. Thank you, Prof. Abdullah. And now, the next speech is Prof. Maman Abdurrahman. So, Prof. Maman Abdurrahman is a distinguished academic and researcher at Telkom University Indonesia, where he has served in the Faculty of Informatics since 1999. He has led numerous strategic leadership positions at Telkom University, including manager of the Telkom University Library, manager of institutional and language development, dean of the Faculty of Informatics, and director of Bandung Technopark. He currently serves as the head of the Center of Excellence for Advanced ICT Infrastructure and Services at the Telkom University, where he continued to promote innovation, collaborative research, and the advancement of smart digital infrastructure. Please, the floor is yours. So we apologize that due to the time limitation, the speech from Prof. Maman will be shortened. I'm sorry for the inconvenience.
Yeah, 5 minutes. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, distinguished speakers, and also distinguished guests and researchers and industrial partners. I would like to thank the organizing committee for having me here as one presenter in this second international conference on smart mechatronics, ICSMech 20 and 26. And in this afternoon, I would like to present and to share our research journey or our research experience with the topic emerging smart technologies for precision, efficiency, and intelligence automations. And currently, I serve as head of CEO, as mentioned before, and also as a coordinator of talent and professional certifications in Association of IoT of Indonesia. Okay, before talking more about and discussing more about smart technologies, I think this important conceptual model regarding the Internet of Things and also cyber physical system. So all participants you can find this document based on international telecommunication unions. So these documents under next generation network framework overview of the Internet of Things. So Internet
Internet of Things has been defined by ITOT as a global infrastructure for the information society, enabling advanced services by interconnecting both physical and virtual things based on existing and offering interoperable information and communication technologies. And inside this document, there is a conceptual model of a cyber and information world. So ITU defined two domains, the physical world and also the information world, or maybe well known also as a cyber world. So this is the conceptual model of cyber physical system. In detail, all of you can find this document based on ITUT standard. And why? There's a big question, why smart technologies matter? Why we need the smart technologies? Okay, there are many reasons why we need this smart technology, including some global challenges here. For example, like increasing operational complexity, more complex systems, so it needs more smart system. And also rising energy consumptions, demand for real-time information, security and safety requirements, and need for sustainable development. So those are the reason why we need the smart technologies in the real world. And to make it in the real life, implement in the real life. So there are many key characteristics of these smart technologies and underlying technologies to support the smart application or maybe smart platform or smart system, such as connectivity. This is the most important thing because the system can share information and between one system and another system based on this interconnectivity. And then context awareness, adaptability, automation, and also the most important things today is intelligent aspect. So those 5 key characteristics will become the mandatory systems, mandatory subsystem that must to support the smart technologies. Okay, so today I would like to share me and my team research journey regarding the topic of smart technologies. There are 4 research domains that have been conducted for about 10 years, including smart card system as a digital identity. We have deployed this system in some universities in Indonesia, and also we are supported by industrial partner. And second one, also we have deployed and we have defined the smart secure virus storage room control and monitoring system. This is the smart secure system that have been deployed in one corporations here in Indonesia and Bandung also. And the third, smart lighting system. Smart lighting systems that's control the LED lamp in building, and this is a part of smart building system. And the last, smart tech system for real-time visibility. This deploy for supply chain visibility management system. Okay, the first, our research domain is smart card system. Okay, this system also for this system we have collaboration in between university and also industrial partners. There are 4 universities that's as a member of a consortium. So the consortium such as Telkom University, Bandung Institute of Technology, Indonesian University, and also Hasanuddin University. And there are industrial supportings like PT Inti, Sirka, DAM, IBS, and Versatile. So currently, this research, we have deployed some smart card system for student identity in 4 universities. And also we have established this consortium as known as Consortium Smart Card Indonesia. So this is the example of student identity card as a result of this research. And as part of this research, also we define secure single, SAM, and multiple card system for smart card readers. And some output we have published in some international conference and also international journal. For example, like you can find this document based on our Google Scholar, like secure smart card reader for university percent systems, and also increasing the security of RFID-based classroom attendance system with Shamir Secret Share. So this is the first research that's have been conducted by our team. And this is the second domain research. We have designed the Hestia. The Hestia system is IoT-based virus storage security using OpenMTC platform. This OpenMTC platform is a machine-to-machine communication platform that has been defined by Fraunhofer Focus Germany. And we have a research collaboration in between Telkom University, Telkom Corporation, and also Fraunhofer Focus Germany. And this system have been deployed in biopharma. And also thank you very much to BRIN, because this research have been awarded the research grant from BRIN through PPTI scheme. So this is the virus room storage system that have been deployed in biopharma corporations. The third IoT-based smart lighting system for intelligence building. Also, we have partnership with PT Inti and Biopharma Corporation as early adopter of the system. And this research have been funded by LPDP through RISPRO scheme. So these are the systems we have deployed in biopharma. Okay. So this is the video demo that show the smart lighting for LED lamps. And based on our research, the results show that there is a economical, more efficient 13% of power consumption based on before and after you use this smart lighting system. And there are also some publications regarding this research. For example, like improving peer sensor network-based activity recognition with PCA and KNN. And also the second one, machine learning methods in smart lighting toward achieving user comfort as a survey. Okay, so also you can find this document based on our scholar. And finally, the last, and currently we still ongoing in this research, SmartTech IoT Analytics Dashboard. This research about real-time supply chain visibility platform. Also, we have got the research funding from Ministry of Education and Higher Education, Science and Technology. And we have implemented also in PT Honda Motor in Karawang and also in Jakarta. And we have defined this Q Delta framework to support this system And you can find this conceptual model in this publication, Q delta, a novel GA autoencoder anomaly detection for logistic tracking using quantizations. Okay, so there are four research domain in smart technologies. Okay, and then until now we still have we still face many challenges here. For example, like the infrastructure, public infrastructure, I mean, and then the economical condition and government regulation, and in the end, finally, we faced the challenge regarding the security issue. As you know, that's PDP law, PDP Act has been approved since 20 and 22 in Indonesia. So it is important because Internet of Things, cyber physical system, and smart systems mostly use personal data. For example, like if you want to know the movement of the people in one place in public place. Also, if you take some picture, some video using CCTV or the others equipment. So currently it has become the important issue because we have a PDP law. So I think this is one important challenge for us in deployment of smart technologies. Okay, thank you very much for attention. Assalamualaikum warahmatullahi wabarakatuh.
Please applause. Thank you, Prof. Maman, for very exciting research in the RCT and smart system. Okay, we have witnessed three exciting keynote speech from hybrid robot, then EEG and signal processing, and then ICT and smart system. Next, we'll move on the question and answer section. So for the offline participants, so you can write, and please, this question is for whom you want to ask. And then for the online participant, so you are welcome to ask, and please mention to whom the question is for. So is there any question?
Hello, thank you for three fascinating and very different talks. I have a bunch of questions, but one, I'll just start with one to Keisuke. I've been in robotics for just over 2 decades, a little while, and one of the most interesting areas has always been sort of tiny robots, tactile robots, but it doesn't seem to have got the funding that generative AI and other fields have had. If that field had had 1,000 times more funding and industrial interest over, say, the last 10 or 20 years, do you think it would have made a difference to progress? Would it accelerate things even faster? Or do you think it's the nature of the field?
Thank you very much. Nice question. Yes, biohybrid is so it's not new, but it's okay. So right now, so robotics and automation community, so especially okay. So how we can utilize, okay. So sensing, okay, sensor in nature, so it's like a perception, okay. So we can compete the synthetic conventional sensor compared with whatever it's sensitivity, like so someone of the good example is a odor sensor. Odor sensor is can detect one single molecule. So this is a very specific application, but so the artificial sensor, a conventional sensor, cannot detect. So this is a more it's it's a very killer application. But how we can produce and how we can manufacture, how we can maintain these devices, when we want to use for the quickly for use, that is okay. So so today I show you the bioactuator, muscle-based actuator, and also cyborg insect, so biohybrid robot. That is okay. So yes, so for example, biomedical application, biomedical. So we need to save the life. Keep the so implantable devices, implantable sensor. Okay, this is so in medical doctors always looking for so advanced sensing technologies and also prosthetic devices. So this is the one of the application, but yes. So yes, the biohybrid systems and okay, 10 years, 20 years, 30 years, okay, so far. So humanoid, for example. So humanoids already established fundamental things. Dynamics modeling is all 30 years ago. It's done. But now, so motor, electrical motor, and also computation, edge computing is now we can utilize this one. So then a lot of startup company and then a lot of people is utilize this technology. So this is it's the same history. So think as you can see, I studied the microfluidics lab on a chip in the microspace, so we can culture the various kinds of cells, human cell. So this is the organ on a chips technology, human cell on a chip. So this is the kind of sensor, so yes, this is a sensing area devices. So one of the biohybrid devices in a large scale integration, that is a very big problem. So microfluidics MEMS, so we can integrate the circuit, semiconductor, but also we can immobilize the molecule, the biological cell, and then tissue, right? This is it's called organoid. So this is now okay, we cannot utilize the animal experiment. So this is the only biomedical application, but that's from 2D to 3D structures, like a bone, like a muscle. That is the challenge. So, and a lot of people from robotics, mechatronics, so study so far is lightweight actuators and the powerful actuator. So some people using a polymer, okay. Also SMA here. Everything mostly is driven by the electrical energy. This means we need battery, lightweight battery, but maybe 10 years, 20 years, 30 years, lightweight battery is will be realized. Okay, the advantage of the biohybrids also. So just the culture, sorry, this is very, for example, culture meat. This is also, I think, revolution to the robotics technology. So now, so everyone invest to the food industry to develop the culture meat. But this is made by muscle cell. So one of the applications of from 2D to 3D, and then circulations, how to integrate circulation system to keep the maintain the muscle. Yes, that is still it's a lot of frustrated as a stage. Okay, how we can invent the flying micro flying robot? That is also everyone's dream. Like drone is a lot of progress. Okay, but insect science, flight muscle, that is still hardware programs, the control program. But in nature, it's a reality. So yes, that is we should continue to study the interdisciplinary field, the robotics people, and also biomedicals or biomaterials, and also how design, how we can learn from the natural architectures, the biological systems. Sorry, this is I'm from the mechanical engineering, MEMS, microfluidics. I learned the chemistry, the postdoc, and biology stuff. So I was still frustrated because we have not achieved the real application. But it's I think this is a very important step forward to moving forward. Keep doing research. Not so. It's humanoid, android, and then so okay, organoid is from cell level, Israel. The cyborg is okay. So combine the synthetic fire. Okay.
Thank. Any other question? Okay. Is there any question from the online participant? We only have 6 minutes. Okay, we still have 6 minutes. Is there any question?
Okay, thank you very much for the opportunity. I want to ask a question to Professor Keisuke. Okay, and my question is, my name is Shafiq. I'm from National Formosa University. My question is about the muscle tissue, or how you mimic the muscle tissue to move the micro muscle hand. And actually, I have something in my mind about that process. It's about the protein react on the UV light. And my question is, will the mimic protein, after they successfully make the prosthetic hand to move, will it be healed, or will it be recover, or it's just one-time use? And what is the function of that motion? Is this just to verify whether that study is successful, or are there any other advance after that? And I'm actually amazed with your finding. I think it's one of the big novelties in this research. Thank you very much for your contribution.
Thank you. Thank you for the question. Okay, the first, as far as I remember, the first question is about how Professor Manusia mimic the artificial muscle in order to move muscle, right? In order to move, for example, to move maybe 1 degree of freedom, what is the principle of the motion? And the second one is maybe about how Mauricio can integrate this actuator, yes, for example, for grasping motion and etc. Yes, thank you. So,
Also, UV stimulation.
yes, okay, protein.
Three question. Okay, sorry. First, so you mentioned micro hand.
Micro hand, yes.
So I show you the video. Micro gripper.
Yes.
Prosthetic hand.
Yes, the micro.
Okay, this study. Okay, so this is a concept. The different new approach to study the how to say the human brain. So professor shows a anatomical study. So very complex. So study everything. So our proposal using micro hand prosthetic. So we call micro hand driven by muscle, skeletal muscle. It's a very simple two structures. One is a gripper structures, mechanical parts, and second is only actuator made by muscle. Okay, so in general, in principle, muscle is driven by neural signal. Okay, neural signal is electrical. So it's a very weak electric signal. Okay, when we apply the voltage, the muscle cell it contract. Okay. So our first idea. So we move the arm. Okay, but unconsciousness, right? But now I want to move. I want to grab it. Okay. But it's very but in the robotics we need algorithm, right? To demonstrate arm. Okay. To make a program. Okay. So how? So there are lots of actuators. Okay. Motor control. So skeletal muscle is real biological muscles. So stimulate. This means simple explanation. We practice. Then we can do it better and better, right? So this means muscle is learning. So we stimulate. We like to optimize stimulation and then learning. So to observe how muscle learn from the stimulation. Okay. So, but if we use very simple experiment. Okay. So professor's approach EEG, EMG. We have a lot of body signal, but a lot of muscle and a lot of complex signal transaction, right? So we, our model is very simplified. Then we like to yes, this is just micro hand for understand the mechanism relationship between muscle and stimulation signal. It's a very simple but still it's unknown in our experiment muscle is if we apply the electric field again and again, and then construction speed, construction efficient is getting better. That's the motivation for us. Okay, so maybe second question. So another UV stimulation, protein microactuator, printable muscle.
Yes. So the motion, it will be repeatable, or it is just one-time
yes.
demonstration?
Thank you for your question. Not yet. Yes. So we published the paper. The result. It's one way, so not reversible. But we are now successfully demonstrating it's reversible. So depending on the architecture, molecule design, so collaboration work with the biochemists. So theoretically we can do it, but it's now in preparation for the publication. Unpublished work.
I see. Thank you.
Okay, thank you, Prof. Risma. Maybe one question for Prof. Abdul Ahad and also Prof. Maman. Is there any question?
So my question is for Professor Abdul Wahab. Yeah. Because in Indonesia, the number of ADHD children is increasing. So we now find many children with ADHD. Do you find any finding that's analyze what is the cause of this? The increasing of a number of children with ADHD. That's the first one. Second one, when we see the you mentioned in your presentation the classification, right? So is there any mitigation method, or the second one, is there any intervention device but not harm us? Maybe Elon Musk who installs a microchip in a monkey, but it's more safer than the others. The intervention device for these children with HDAD. Thank you.
Okay. Can you repeat?
Okay, the first one, in your research, do you find any conclusion about the cause of this? So many children now in Indonesia, or maybe in your country, in Malaysia,
that you have. Example I give you. There is a number of increase of a student committing suicide. And we have a lot of suicidal cases, you know. So why does that happen? So we wanted to know. And because of that, the best way to do it right today is to profile. Profiling not only based on some psychological understanding, but profiling even with the brain. In other words, we want to know what is happening, you know, as far as these kids who are in school. So therefore, these profilings need to do with what we call vertical study, not just one time and we get all the answers. We have to do it on the vertical study. And this study will take time. But we have to start somewhere as far as profiling this particular student. So right now, what we are doing is that we are working together with a software development company, and we're trying to get a grant from the government to actually develop this entire, what we call profile-based study of the individual mental well-being as far as kids are concerned, because it's very important. Unless otherwise we can understand that the future of our kids will be at stake. We really do not understand what is going to happen to our future, and we continue have this problem of mental health. Student start to cut their, arm, Why? Because they watch a lot of anime and they get excited, and then they start doing that. So therefore, this kind of study are not that straightforward. It requires a lot of vertical studies. So is that what you're referring to? So because I think in this particular context, yes, I agree with you, but it's not that straightforward. There are a lot of things that we need to really take care of.
Yeah, the HDHD actually is from the born, right? It's not behavior like, ADHD, like we know it's not caused by behavior like reading animals, something like that. It's because from the beginning, when they're born, and we find there's something wrong with our boy, is we call it autism, something like that, right? Because the rise number of autism children in Indonesia, maybe in Malaysia, I don't know. Could you describe what is the cause of so many children?
Okay. As far as behavior are concerned, when we talk about behavior, we use the psychological instruments to understand behavior, because behavior are long-term. We're not talking about the short-term behavior. So therefore, there must be a way to differentiate between the short-term behavior and the long-term behavior. So if you look at the psychological instruments like the big ocean behavior that I was talking about, the OCAAN. Now, these 5 big ocean behavior are very popular, okay? And they actually tells you more about your inner behavior rather than what you think about it immediately. So therefore, what best in this particular case is to look at your EEG, in order to understand your internal behavior. That is why when you start to close your eyes, the performance of your EEG when you start to close your eyes is your initial behavior. Example I give you, when someone in Palestine, they have been day in, day out, looking at war, seeing at war, experience war. Their fear for war is very different than us. But the way for us to know it is that is why we have to look at what we call the initial stage of the EEG. And that initial stage become important, which is the eyes open and eyes closed. Therefore, if you find in any kind of EEG study, you must have these 2 things, eyes open, eyes closed at the initial, because that will really tells you how the individual behave, okay, without affecting any of the outside environment. When I start giving you some mathematical, the problem, you start to solve it, that has a already external factor, okay? So therefore, that is already a different kind of behavior. When I do the use stress and de-stress, I have to really stimulate you with that kind of situation so that I can now know what is the limit as far as your use stress and de-stress. But when I want to know about your behavior, it talks about the long term. That is why in this case here, we have the study of mood and emotion. What's the difference between mood and emotion? Mood is the integral emotion, right? When you integrate mood, you derive emotion. When you integrate emotion, you derive mood. So mood is more long-term compared to emotion. So sometimes when I ask, are you referring to the mood or are you referring to the emotion of that individual? So this is something very important. That is why when we do all this, especially when you talk about emotional robots, so you really have to understand the psychological effect of it, because in the end, the human or our kids are going to use them, as far as the emotional robots is concerned. So therefore, it's good that we really try to understand or work together with the psychologists or the psychiatrists in this case here to help us understand better of our own emotion and how we establish that. Okay, there are a lot of studies. Like for example, you can use what we call the SEM, SEM. These are the self-assessment mannequin, to actually understand the emotion and how we actually derive that. Okay, it's an interesting study. Don't be scared of it. That's what I'm trying to say. And yes, it's not really that bad. But when you understand this, because whatever that you do, you want to control what do you call that? Robots, So in order to control whatever movement, ship's movement, and so forth using the brain, you must really understand there are limitations. And what are the limitations as far as the brain is concerned? So therefore, then you can control better, you can compensate better. It's not that you cannot do it. You can do it, but you have to be realistic about it.
Okay, thank you, Professor Abdullah. Thank you for the answer. So, in the end of this plenary session, we will close this plenary session. So, we are lucky to get the very good, exciting research from 3 distinguished professors here. So, please give applause again. So, thank you very much. On behalf of the moderator, we will close this plenary session. Thank you. Now, I will return back then to the MC. Thank you very much.
Ladies and gentlemen, that was a truly stimulating and enriching discussion. Our censure, thanks to our 3 distinguished panelists for sharing their expertise, and to our moderator for guiding such a rich conversation.
Please join us
in
in
thanking
thanking
them
them once more.
To express our appreciation, we would like to present a token of appreciation to our 3 distinguished panelists and moderator.
May we invite the chairman of ICSMech 2026, Dr. Roni Permana Saputra, to present the plaque. Please come forward to the stage. To our panelists and moderator, please come forward to the stage. Thank you to the chairman of ICSMech 2026, to our moderator and our panelists. Please have a seat again. Please give a round of applause.
This brings our plenary program to close. Thank you all for being part of wonderful opening day.
Our programming will continue with the parallel technical session at 3:40 p.m. On-site presentation will take place in room R1 and R2, and our virtual session in rooms P1, P2, and P3. Please make your way to your assigned room. The room and schedule are in your programming.
To our online participants, please join your assigned to virtual room. We wish everyone productive and engaging session.
Ladies and gentlemen, we will now take a short break. Refreshments are available in the pre-function area.
Do also take a moment to visit the BEST 2026 exhibition beside the registration desk.
Ladies and gentlemen, as we are about to move into our parallel session, we kindly ask that you please take all of your belongings with you when you leave the main hall. Thank you for your cooperation.
Selanjutnya adalah sesi coffee break. Kepada Bapak Ibu, disilakan untuk membawa barang karena selanjutnya adalah parallel session. Terima kasih.